Hello friends, welcome to my channel. My name is Mr.Adebanjo. In this video we are going to be discussing matrices. We are going to be talking about matrices together in this video, and this as a result of a student who requested for this video, and I've made up my mind to explain what matrix is all about in this video. And what are we going to be doing in this video? We are going to be first of all telling you the differences between row and column. Before you understand the matrix, you must know the difference between a row and column in the arrangement of things. And also we are going to be defining what matrix is all about with examples. And also we are going to be teaching you how to find the order of matrix, and also types of matrix as well. And also we are going to be teaching you how you can find the notation or give the notation of matrices as well. And also we are going to be teaching you how to find the addition and subtraction of matrices, how you can add and subtract matrices from one another. And also we are going to be multiplying a matrix by a scalar. And also we are going to be talking about how we can multiply two or more matrices together. And also we are going to be teaching you how to transpose matrix. Then also we are going to be talking about how we can find a determinant of 2 by 2 matrices, and also determinant of 3 by 3 matrices. And also we are going to be teaching you the equality of matrices and the implication of their equality. And also we are going to be finding the inverse of 2 by 2 matrices, and we are going to be solving simultaneous equation using what you have learned so far. So this video is going to be two-part video. This is the first part, which is going to address everything you have seen on the screen right now as a subtopic under matrices. And there is also few topics we are going to discuss in the next video, which we address some of the topics in further mathematics, because matrix is both general mathematics and further mathematics. So everything you are seeing on the screen now addresses general mathematics topics on matrix. Then there are few topics left that is meant for further mathematics students, so that we are going to address in the next video. That does not mean that a general further mathematics student does not need this video as well, because you need to understand everything we are having on the slide right now before you can go to the few topics we have left for further mathematics. So we have a lot to talk to cover as far as this video is concerned. So, and I want you to sit back and enjoy the video. But before we get it started, if you are yet to subscribe to this channel, please click the subscribe button on the channel right now, in order to help you, or in order to notify you whenever we post information on this video, and that also will help us improve this channel. Please share this video with students out there, most especially the SS3 students who are going to be writing exam very soon. They need this topic a lot. Comment in the comment section of this video, then like the video and share it with students out there. So without wasting much of our time, let's get started. The first thing we need to know is how we can identify row and column in arrangement of elements or numbers. How do we identify rows and how do we identify column in the arrangement of numbers or elements or anything? So that's the first thing we need to know, because if you truly want to understand the matrices, you must be able to differentiate between row and column when you see the arrangement of things. You will see that when you are in a classroom, when students are in a classroom, the arrangement of the seat of the student are arranged in such a way that we have rows and we have column. And also other examples, when you see students standing on the assembly ground, the way the students are arranged, they are arranged in rows and also in columns. The question is which one represent row, which arrangement represent row, which arrangement represent column. That first thing we need to know first before we go into matrix per se, and that's what I want to help you understand first. Now look at the arrangement of these students in the classroom. You can see the way they sit in the classroom. Each of them have a seat, and look at the way they arrange the student. They arrange them horizontally like this, they arrange them horizontally like this, and they also arrange them vertically like this, vertically, and vertically. So there are two arrangements in this in the arrangement of the students sitting down in the class. So there's the horizontal arrangement, there's horizontal arrangement, there's vertical arrangement, vertical, and vertical. So out of these two arrangements, one is called row, the other one is called column. So which one is row, which one is column out of these two arrangements? That's the first thing you must know. Now the row is the horizontal one. This is horizontal, which is row, the first row, then the second row. Are we there? So this is the first row and this is the second row, or you can call this one the first row and the second row. So that means we are in this arrangement that we have two rows, and this is the column. The vertical is the column. This is the column 1, column 2, column 3, column 4. So in identifying row and column in the arrangement of things, row is horizontal, column is vertical, as you can see as I'm addressing it using my mouse on the screen. So I can see now this line here represents the first row, so this arrangement represents the first row. Now this is the second row now, as you can see. So horizontal line represents the row, horizontal line represents the rows, while this one, this first one is the first one here. This is the column, the first column, this is the second column, this is the third column, and this is the fourth column. So now with this, now I believe that you understand which one is row and which one is column in the arrangement of these students. The seat arranged like this horizontally is representing row, this is the second row as well, then arrangement like this is the column, second column, third column, and fourth column. So this arrangement has 2 rows, then 4 columns. Now let's see another example. All right, look at the arrangement of egg in crate. The arrangement of egg in crate is also arranged in such a way that we have rows, we have column as well. So if you look at this egg now, can you tell me how many rows has this egg, and how many column has the egg, or where is the row, where is the column for this egg? So now you can see that this egg is like this. So that means this become the first row, second row, third row, fourth row, fifth row, and this is the first column, second column, third column, fourth column, fifth column, sixth column. So that means this egg has 5 rows, 6 columns. So horizontal represent the row, the vertical represent what, the column, as you can see. So that means we have the first row, which is this, we have the second row, we have the third row like this, we have the fourth row, we have the fifth row as well, you can see. So those horizontal line represent the rows. Now the column, this is the first column, this is the second column, this is the third column, this is the fourth, the fifth, and the sixth. So you can see that in the arrangement of this egg, as you can see, this egg has 5 rows and it has a 6 column. Now I want to believe that if you see arrangement of things in rows and column, you can easily identify which one is row and which one is column. So if you sit in a class, by the arrangement of the seat in the class, you should be able to identify where is the row and where is column. Let's see another example. Of course, if you know that we have a bottle arranged in crates. Also, the arrangement of bottle in the crate is also in rows and column as well. So I believe now that you can tell me how many rows and how many columns we have in this crate right now, and where are the rows and where are the columns. You should be able to do that. I will leave that for you. I'm not going to teach you that. I believe you can identify which one is row, which one is column in this crate. Now you can leave the answer in the comment section of this video to help to know whether you truly understand how many rows, how many columns we have for this crate. Another example is the arrangement of seats in this class. As you can see, we can see that the arrangement of the seats in the class here right now is in rows and in column. So this is the row, another row is at the back, another row like this horizontally, another row, then this is one column, another column is here, another column is here, and so on. So we have a horizontal row and we have vertical column. Now I want to believe that you know how to identify row and how to identify column in the arrangement of things. So having known that, now we can now go back and we can now go to matrix now and see what matrix is all about. Now having understood what rows and columns are and how you can differentiate between them, let's talk about matrix. So matrices is plural, matrix is singular. That's the matrices is plural and matrix is singular. So this one is a singular, this is plural. So matrices is plural, matrices is singular. Now what is matrix? A matrix is a set of numbers arranged in horizontal rows and vertical column enclosed inside a curved bracket. I'll come again. A matrix is a set of numbers arranged in horizontal rows and vertical columns enclosed inside a curved bracket. Now you can see the reason why we're learning rows and column in the previous at the beginning of this video, because we need to know which one is row, which one is column, if truly you want to understand matrix, what matrix is all about. So when you arrange numbers in rows and column, then you now enclose it in brackets. That is what matrix is all about. I hope you understand that. So when you have number in rows and you have them in column, you now close it using brackets, then we are talking about what matrix. Now for example, if I have this, now look at this is an example of matrix. This is an example of matrix. We have some number arranged in rows and in columns and enclosed in curved brackets. So that means this is an example of what matrix. But before I tell you how many rows, how many columns does as this matrix, can you tell me how many rows, how many columns the matrix has, and where are the rows and where are the column? You can pause the video and I try to find out number of rows, number of columns this matrix has. I'll give you 1 second to do that. Alright, so I want to believe that you have gotten the number of rows, number of columns this matrix has. So of course don't forget that a row is the horizontal and the horizontal here. So that means the first row is this one, then the second row is this, and the third row is this as well. So that means this matrix has 3 rows, then the first column is this, and then the second column is this as well. So that means this matrix, as you can see on the screen right now, has 3 rows, 2 columns. Do we understand that? Let's see another example. Another example is this matrix on the screen right now, which also satisfy this definition. Numbers are arranged in rows and column enclosed in brackets. So that means this is a matrix as well. So can you tell me how many rows this matrix has and how many columns it has as well? So this matrix has 2 rows and 2 columns as well. So this matrix has 2 rows and 2 columns. Another example is what you are seeing on the screen right now. Is this a matrix? Yes, it is a matrix because the numbers are arranged in rows and columns enclosed in brackets. Now how many rows, how many columns does this matrix has? Now I want you to figure out that and tell me the answer. So you can see that it has 1 row, second row, this is the third row, first column, second column, and the third column. So this matrix has 3 rows, 3 columns. So now I want to believe that you understand what matrix is all about by saying that matrix is the arrangement of numbers in rows and columns enclosed in a curved bracket. Now let's see other example that we can see. Now I want to ask you, look at this this number and this number. They are arranged in rows and columns, as you can see, but are they matrix? That's the question I'm asking you. Are they matrix? Is this a matrix? Is this a matrix? Is this a matrix? Okay, at least you know the answer now, whether they are matrix or they are not matrix. But I will tell you they are not matrix, and the reason being that although those numbers are arranged in rows and in column, that is, this number has 3 rows, 2 columns. This also has 2 rows, 2 columns. This also has 3 rows, 3 columns. Although they are arranged in rows and columns, but something is still missing as far as definition of matrix is concerned. They are not enclosed in brackets, so that means they are not matrix, or they are not matrices rather. So although the numbers listed above are arranged in rows and columns, yet they are not matrices simply because they are not enclosed in brackets. So don't forget that not only arranging the number in rows and columns that make it a matrix, but those numbers must be enclosed in curved brackets. Do we understand that now? Good. Now let's go to the next thing in our agenda. Another thing in our agenda is how to find the order of a matrix. How to find order of a matrix. Of course, now you can identify a matrix now if you see one by the definition of matrix and what you have done so far in previous slides. You should be able to identify a matrix when you see a matrix now. So having been able to identify what a matrix is, we need to talk about how we can find order of a matrix. That's the next topic, order of a matrix. Now when they ask you to find order of a matrix, or they ask you what is the order of a particular matrix, what they are simply asking you is that how many rows, how many columns has that particular matrix. Tell us the number of rows and tell us number of columns that particular matrix has. That is the meaning of order of a matrix. Do we understand what I just said? How many rows, how many columns does a matrix has? That is the order of matrix. But don't forget, one come before the other one. Rows come before column. So in naming order of a matrix, you must tell us the row first before you tell us the number of columns in that. So order of a matrix implies the number of rows and columns as the matrix. Tell us how many number of rows, how many number of columns that a particular matrix has, and that's the meaning of order of that matrix. So note, when describing the order of a matrix, the number of rows is stated and the number of columns second. So the number of rows is stated first, and you say this number of column after the number you have stated number of row. Now in general, a matrix having p rows and q columns has order of p times q, which is read as p by q. So let's assume I have a matrix and the matrix has p number of rows and q number of columns. If I want to say the order of that matrix, I'll say it is p by q. P by q, and this times represent, it means by when it comes to matrix. P by q. So when it comes to order of matrix, we say it like this as well, p by q, which if you want to say it verbally, we say p by q. Do we understand that? Now let's see an example. Now this example on the screen right now, can you tell me the number of rows, number of columns this matrix has? Of course we know that it is a matrix because the numbers are arranged in rows and in column. But can you tell me number of rows, how many columns does this matrix have? Because that is the order of that matrix. So of course you can see that it has a one row. This is the row that it has, and it has 3 columns, 1 2 3. So it has one row then 3 columns. So if I want to tell you the order of this matrix now, that will be 1 by 3. So the order of this matrix is 1 by 3, which is 1 by 3 written like this. So if you are asked to tell us the order of this matrix, it is 1 by 3. Are we there? That's the order of that matrix. Let's see another one. Look at this matrix now. If you ask to tell us the order of this matrix, what will it be? How many rows, how many columns? Don't forget, you need to tell us the number of rows first before you tell us the number of columns. So we have one row, another row making 2 rows, 1 column, 2 columns making 2 columns as well. So that means the order of this matrix is 2 by 2. 2 by 2. That is the order of this matrix. Let's see another matrix as well. So how many rows, how many columns has this matrix? We have the first row, we have the second row, and it has only 1 column. So that means the order of this matrix is 2 by 1. 2 by 1. That is the order of this matrix. Let's see another one as well. How many rows, how many columns? So what will be the order of this matrix as well? It will be 1 2. So it has 2 rows, 1 2 3, 3 columns. So that means it's going to be 2 by 3 matrix. So the order of this matrix is 2 by 3. 2 by 3. So you understand what order of matrix is now by it's telling us the number of rows, number of column that particular matrix has when you have to find its order. Do you understand that? Good. So can you simply tell me the order of this matrix? Still an order of matrix. So of course by now you know the answer by now. So the answer is 3 by 2, 1 2 3, which is 3 rows, 1 2 3 2 columns. Next one, can you tell me the order of this matrix on the screen right now? Now it has 3 rows, it has 3 columns, so it is 3 by 3. Then also this last one, can you tell me the order of this matrix? How many rows, how many columns? It has 2 rows, it has 4 columns, so 2 by 4. So that is how to find the order of a particular matrix given to you. And if you understand that, please you can evaluate yourself with this question on the screen right now. State the order of the following matrices. So it's a self-evaluation question that you need to answer by yourself, so that will help you to know whether you understand what order of matrix is all about or not. So you can leave the answer in the comment section of this video, so that I will respond to you whether you are right or wrong. I hope you understand that. Good. So having understood what order of matrix is all about, let's go to the next topic we have, which is the types of matrices. What are the types of matrices that we have? Now that we know matrix, how we can identify one, and then we know the order of matrix, we need to know the types of matrices that we have. The first one that we have is the first type of matrix that we have is called row matrix. That is the first type of matrix that we have. We have row matrix. So this is the matrix with only one row of elements. So that is when I have a matrix and that matrix has only one row, so that is called a row matrix. A row matrix is a matrix with only one row. A matrix with only one row is called a row matrix. An example is what you're having on the screen right now. This is an example of a row matrix, simply because it has only one row. Are we there? Another type of matrix that we have is column matrix. It's very similar to this. It is a matrix with only one column of elements. That is when you have a matrix with only one column, that is called a column matrix. An example is what you are seeing on the screen right now, which is this matrix. So this is a matrix with only one column, which is what I'm highlighting on now. It has only one column, so that makes it a column matrix. Another type of matrix that we have is called a zero or null matrix. Another type of matrix that we have is called zero or null matrix. This is a matrix having all its elements to be zero. When you have a matrix that all the elements in that matrix is 0, then you call it a zero or null matrix. An example is what you are seeing on the screen right now. You can see that this is a matrix. You can see that all the elements in that matrix, in this matrix, is they are zeros. So that means this is zero or null matrix. Do we understand that? So no matter the order of that matrix, if all the elements inside it are 0, then that is a null or zero matrix. Another type of matrix that we have is called square matrix. Square matrix. So this is a matrix having equal number of rows and columns. So when you have a matrix that have equal number of rows and columns, we call it square matrix. Any matrix that you see which have equal number of rows and columns, then that is a square matrix. Then you can see this is a square matrix because it has 2 rows, 2 columns. So we call this one 2 by 2 matrix. 2 by 2 square matrix, because the order of this matrix is 2 by 2. I believe you know that from this previous topic that we learned. So the order of this is 2 by 2, but it's a square matrix because it has the same number of rows and the same number of columns. Another example of square matrix is 3 by 3 as well. 3 by 3, that is, it has 3 rows, 3 columns, so it has equal number of rows and columns. That's another example of a square matrix. So if you ask to give me the 2 example of square matrix, you can tell me it is 2 by 2 and 3 by 3, even 4 by 4, 5 by 5, 6 by 6. Those are square matrices. Do we understand that now? Another type type of matrix that we have is called identity or unit matrix. Identity or unit matrix. That one is represented by capital letter I. It is represented by capital letter I. Capital letter I. That is what we use to represent identity or unit matrix. So it is a diagonal matrix in which the elements on the leading diagonal are all unity. That is, when you have a matrix and the leading diagonal, one of the diagonal there has all its number to be 1. Unit means 1. All the numbers in that diagonal are 1. That is an example of a unit matrix. So example is this, which I have on the screen right now. You can see that, look at this, is a matrix, but look at this leading diagonal, this diagonal here, not this one. Oh, this is the leading diagonal. You can see that this is 1, this is 1, and the rest of the number are 0. So that means this is an identity matrix. Another example here, you can see that the leading diagonal here is 1, 1, 1. The rest of the numbers are 0. So that this is a 2 by 2 identity matrix, and this is 3 by 3 identity matrix. Do we understand it now? So if someone asks you to give an example of a 2 by 2 identity matrix, you should know that identity matrix, the diagonal, all the elements in the leading diagonal are unity, that is, they are 1. So then the rest of the number are 0. So we have 1, 1, then 0, 0. Then 3 by 3 identity matrix as well. We have 1, 1, 1 here, then the rest of the number are 0. So these are the two types of identity matrix that we have for under this discussion. Now these are the types of matrices that we have, from row to column matrix to zero matrix to square matrix to identity or unit matrix. So these are the types of matrix that we are going to be seeing or use in this this video. Now that we understand the types, or we know the types of matrices that we have, the next topic we are going to talk about is the notation of matrices. Notation of matrices. What is the meaning of notation of matrices? Notation of matrices is talking about how we can name a matrix. How do we name a matrix? We can give a name to our matrix. That is what we are going to be talking about under this topic. We can give a name to our matrix. So conventionally, a matrix is named using capital letter. So we use capital letter to name our matrix, and it means that the element of that matrix will inherit the small letter of the name of that matrix automatically. What am I saying? In essence, matrices are usually named using both capital letters. So we use capital letter to name our matrix, while the element enclosed in brackets automatically inherits the small letters of the name. So what am I trying to say? In essence, if I name my matrix capital letter A, that means all the elements in that matrix will inherit small letter A automatically. An example is what we are seeing on the screen right now. We have a matrix A. You can see that the elements in it are small letter A. So what does this 1, 1 represent? What does this 1, 2 represent? What does this 2, 1 represent? What does this 2, 2 represent? They represent, this one will help us to differentiate between this element and this element, this element and this element, knowing fully well that all the elements in this matrix will inherit small letter A of this name, but this 1, 1, 1, 2, 2, 1, 2, 2 help us to differentiate between this one and this one, this one and this one. So what does this 1, 1 represent? Don't forget that this element is in the first row, is in the first column. So that's why we are having A11, 1, saying that this element is in first row, first column. That's what this 1, 1 represents. This small letter A represents that this element is in matrix A, but this element is in first row, first column. That's what this 1, 1 represents. This element is in the first row but second column. That's why you're having A12. Do we understand that this element here is in the first row but it's in the second column, because this is the first column, so this is the second column. So this element is in the first row, second column. You have A12. Then look at this one. This element is in the second row but first column. That gives us a 2, 1, A21. the element is in the second row but first column, A21. Then this one is in second row, second column, A22. Do we understand this now? I want to believe you understand. So A11 remains first row, first column, A12 first row, second column, A21 second row, first column, A22 the element in second row, second column. Don't forget, in naming the, when we talk about order of matrix, we said the row come before column. So you must, the first number represent row, second number represent column. So this is first row, first column, second row, first column, and so on like that. Let's see another example. Look at this matrix as well. We have matrix X. So that is the name of this matrix is capital letter X. So technically all the elements inside the matrix will inherit a small letter X. But how do we differentiate between the elements in them? We have S11, S12, S13, S21, S22, S23, saying that this element is in the first row, first column. This element is the first row, second column. This element is the first row, third column, S13. Then look at this one as well. This element X is in the second row, the first column, S21. This element in the second row, second column, S22. This element is the second row, third column, S23. Another example. Look at this on the screen right now. The matrix is named capital letter Y. That means all the elements in it will inherit small letter Y, as you can see. But how do we differentiate between each of the elements? We have Y11 to Y33, which I believe you can interpret each one of them for us. Like this last one here, this element Y is in the third row because it is the first row, second row, third row, first column, second column, third column. So this element is in the third row, then third column. Do we understand that? This element is in the third row, third column. That's why you're having Y33. This element here is in the second row, second column. That's why you're having Y22. This element is the first row, first column. We have Y11. Also the rest as well. I believe you can interpret this. This one is in the second row, first column, Y21. This one is in the second row, second column, Y22. Second row, third column, Y23. Then this one is in the third row. As you can see, this is the third row, first column, Y31, and so on. And that is what notation of matrices is talking about. How we can name our matrix and how we can differentiate between the elements in the matrix. Do we understand that? If you understand that, let's see these examples. Now we have this first element, this first matrix called matrix B, and by now you should be able to tell me the order of this matrix. If they ask you what is the order of this matrix, can you tell us the order of the matrix? So it is of order 3 by 2. It has 3 rows, 2 columns, so it is of 3 by 2. Now from this matrix, now you have to determine B21, B32, B12, and B22, knowing that this is matrix B, so all the elements inside will inherit small letter B. So this number now are going to be used to find the elements in the matrix. So can you determine B21 for us, B32, B12, B22 for us in this matrix B? I want you to pause this video in 1 minute. Try to identify B21, B32, B12, B22 for us quickly. I believe you have done that by now. Now let's start. Now for B21, that means the element is the second row, first column. Where is the second row? This is the second row. And where is the first column? First column. So second row, first column, that means the element is in what? Is -5. Then for the next one, B32, that means 3 represent the third row, second column. Third row, second column, that will be what? 0. Then B12, that should be first row, second column. First row, second column. First row, second column, that will be what? Sorry, this is the first row, pardon me for that. First row, second column. This is first row, second column, that will be what? 2. Then for the last one, which is number 4, B22, that should be second row, second column, second row, second column. That will be 7. So you can see the usefulness of the notation of matrix. Now you can use this notation of matrix to pluck out the element of a particular matrix when we know the name of that matrix. Do you understand this? Alright, let's see another one. We are given these two matrices, given matrix A and matrix B. So you should be able to tell us the order of this matrix if they ask you to tell us the order. But let's see what they want us to do with these two matrices. Given that matrix A is this and matrix B is this, now state the order of matrix A and B. That's the first question. State the order of this matrix, state the order of this matrix as well. Then question number B, determine A13, A24, B21 and B12. So let me give you 1 minute or 2 minutes. Now you can pause this video and try to attempt the question, the two questions yourself, before you will now continue play the video to know if you are right or wrong. Now I want to believe you have done that by now. Now let's see the solution. Okay, sorry, there's still third question which says that what type of matrix is B. Sorry for that. There's still third question that says what type of matrix is this matrix B. Alright, now let's see the solution. You have to state the order of matrix A and B. By now you should know the order of this matrix, and you should know what the meaning of order. How many rows, how many columns. That's the meaning of order, which is what we have talked about before. So matrix A has 2 rows, 1, 2, 3, 4 columns. So this should be 2 by 4. So matrix A is of order 2 by 4, while matrix B has 2 rows, 2 columns. That should be 2 by 2. So the order of matrix A is 2 by 4 and the order of matrix B is 2 by 2. That is the first question. Now from question number B, you have to determine Roman figure 1, A13. A represents that the element is in a matrix A, because this small a, that means we are talking about the element in matrix A. 1, 3, that is first row, third column. First row, third column, 1, 2, 3, 4. This is the third column. So the first row, third column, that should be what? -1. So A13, sorry, I've made a mistake there also. A13, this is 1, 2, 3. I know you have seen the mistake also. A13 is the first row, third column. 1, 2, 3. This is the third column here. This is the first row, the third column. That should be this element here, because this element is the first row, third column. So this 0 here is A13. Sorry for that. So let's see the next one, A24. A24, that means we are still talking about the element in this matrix A, but the element is in the second row, fourth column. Second row, fourth column. This is the second row and this is the fourth column here. So that means the element is also 0, which is this one here. Then B21, that means the element is in matrix B, not in matrix A again. Matrix B, but the element is in the second row, first column. Second row, first column. This second row, first column, that means the element is what? Is 2. Then B12 as well, the element is in matrix B, but the element is in the first row, second column. First row, second column, that will be what? 7. So first row, second column, that will be what? 7. So and the last question, we have to tell us the type of matrix which is B. What type of matrix is B? By now you should be able to tell us what type of matrix, because they can ask you that in exam as well, which is like 1 or 2 marks. So that's why you should know the types of matrices that we have, which is what we have already discussed in this video as well. I've listed all the type of matrices that we have, and you should be able to tell us which category this one belongs to. So it belongs to square matrix. So matrix B is a square matrix. So that's the solution to this question, which I believe that it addresses everything we have learned so far under matrices. Do you understand that? Now if you understand that, please attempt this self-evaluation question by yourself based on what you have learned so far. You have matrix P, matrix T, matrix S. Then state the order of the matrices above. You have to tell us the order of these 3 matrices, and then now from there you have to determine all the elements of all these elements for P4, 3 and so on using this matrix. And I believe you know which one you have to use out of these three matrices for each of the question here. So attempt the question and you leave the answer in the comment section of this video, and I will address to that shortly. Now, having understood that, now the next thing we want to do is how do we add and subtract matrices. Addition and subtraction of matrices is the next thing we want to talk about. Addition and subtraction of matrices is the next thing we want to talk about. So we are talking about addition and subtraction of matrices in this slide. That is, how do we add and how do we subtract matrices from one another. Now, the first thing I want you to know when it comes to addition and subtraction of matrices is that there is a condition that must be satisfied before you can add and subtract matrices. There is a condition that must be met, or that must be satisfied before you can add or subtract matrices from one another. That is, if that condition is not satisfied or not met, then you cannot add matrices. You cannot add them together or subtract them. Just like when you are adding when it comes to addition of likely things, I can add x to x. X plus x will give us 2x. So, but when it comes to x plus y, we know we cannot add them together because they represent unlikely terms or unlikely things. So I cannot add a barrel to a keg. So I cannot also add a goat and ram together. No, they are unlikely things. But we can add goat plus goats together. That gives us 2 goats. So the same thing, the same condition is applicable to matrices as well. When you are adding them together, there is a condition that must be satisfied, and the condition is that before you can add 2 or more matrices together or subtract them, they must be of the same order. So those matrices that you want to add or subtract must be of the same order. This condition must be met or satisfied before you can add matrices together or subtract them. Of course, we know the meaning of order by now. We have talked about order of matrix before. So that means if I want to add 2 matrices together, they must be of the same order. That means I can add 2 by 2 to 2 by 2, 3 by 3 to 3 by 3, 4 by 4 to 4 by 4, and so on like that. So they must be of the same order before we can add or subtract them from one another. Example is this matrix. Can we add this and this together? Yes, we can add them together because they are of the same order. This is 1 2 this has 2 rows, 1 column. This is 3 by 1, and the same thing that this also has 3 by 1 as well. This is order 3 by 1, 3 by 1, so that we can add them together. So it is possible that we add them together. Excuse me. Another one is that, can we subtract this matrix from this matrix? Is your answer yes or no? Or is it possible for us to add them together, to subtract them from one another? Is it possible for us to subtract them from one another? Yes, it is possible because they are of the same order as well. So it is possible we can subtract this from this. Next one, can we add this matrix and this matrix together? That's the question. No, we cannot add it. You cannot subtract them. You cannot add them together. It is impossible because this is 3 by 1 and this is 2 by 2. We can't add them together. So it is what? Impossible. So before we can add, don't forget, before we can add 2 or more matrices together, they must be of the same order. So I can test you on this. I do test my students on this as well. I will just give them matrices that are not of the same order. I will ask them to add and subtract. I want to test whether they still remember the order of matrix or they are forgotten. They still remember the condition for addition of matrix or not. Having understood the condition for addition and subtraction of matrices, let's see how we can add matrices together. Now look at this question on the screen right now. You are given that we have matrix X, which is of order 2 by 2, and we have matrix Y, which is of order 2 by 2 as well. You have to determine X plus Y, Y plus X, X minus Y, and Y minus X. So we have to add them together. So the difference between this one and this one is that X come before Y here, and this Y come before X here. The same thing here, X come before Y, Y come before X. So the question is, can we add them together and can we subtract them from one another? That's the question. The condition for addition and subtraction, is it met in this question? So the answer is yes, because they are of the same order, 2 by 2 and 2 by 2 square matrix. So we can add them together. So let's see how we add them together. For the first one, which is we have to add matrix x plus y. So we have matrix x here, which is this, plus matrix y, which is this. So we can add them together because they are of the same order. Then how do we add them together? It's very simple. The first element here, the elements in the first row, first column here, will be added to the elements in the first row, first column here. So we have 3 plus 6, which is this, which is what you're having here, 3 plus 6. Then the second one also, we have the element in the first row, second column here, which is 5, will be added to the element in the first row, second column here, which is 2. So you have 5 plus 2. So here you have a 4 plus 0, which is this. You have 6 plus 3, which is this as well. So 3 plus 6 will give us 9. Then 5 plus 2 will give us 7. 4 plus 0 will give us 4. 6 plus 3 will give us 9. So which is giving us another matrix, which is also 2 by 2 matrix. So technically, if I add 2 by 2 to 2 by 2, it's going to give me 2 by 2 matrix as well. Do you understand that? And that's how we add, or that's how we subtract matrices from one another. So this plus 3 plus 6, 5 plus 2, 4 plus 0, then 6 plus 3, which is what you're having here. Let's see the second one as well, y plus x. So that means matrix y will come first, plus matrix x, which is this. So you add as well. 6 plus 3 will give us as this. 2 plus 5, we have this. 0 plus 4, we have this. 3 plus 6, we have this as well. If you simplify further, we have 6 plus 3, that give us 9. 2 plus 5 give us 7. 0 plus 4 give us 4. 3 plus 6 give us 9. So you can see that s plus y is, which is this, y plus also, which is this. You can see that they are, this one and this one are the same thing. So it means that when it comes to addition of matrices, in the addition of matrices is commutative. It's commutative because 2 plus 5 will give us the same thing as 5 plus 2. So addition of matrices is commutative. We get the same answer when you have s plus y, and then when you have a y plus you're going to give us the same answer. So another question can say that given this matrix and this matrix, show that this is equals to this. So that means all you need to do is to add this together, whatever you get must be the same thing, which is this and this as well. So that is how to add matrices together. We are going to see another example very soon. So let's talk about the subtraction part of it. X minus y. So this is matrix y minus, sorry, this is matrix s rather, minus matrix y. How do we subtract? The same way we had 3 minus 6. We have 3 minus 6 here. 5 minus 2, we have this here. 4 minus 0, which is this. 6 minus 3, which is this. Then you simplify. What is 3 minus 6? That gives us minus 3. 5 minus 2 is 3. 4 minus 0 is 4. Then 6 minus 3 is 3. So which also gives us another 2 by 2 matrix. Let's see the last one, which is y minus x. So we have matrix y minus matrix x. So you subtract as well. 6 minus 3, which is this. 2 minus 5, which is this. 0 minus 4, which is what you're having here. 0 minus 6, which, sorry, 3 minus 6, which is this as well. And if you simplify, 6 minus 3 give us 3. 2 minus 5 is minus 3. 0 minus 4 is minus 4. 3 minus 6 is minus 3. So we can see that the answer of s minus y is not the same thing as y minus x. The answer of this one is not the same thing as the answer of this one. They are different answer. So we can say that a subtraction is not commutative in matrix. Subtraction is not commutative in matrix. That is, the answer you get for this one is not the answer you get for this one. So but addition is commutative. So that is how we add and subtract matrices from one another. Let's see another example. We have this matrix H and matrix L. We are to add and we are to subtract. The question is, can we add them together? Can we subtract them from one another? That's the question we need to ask ourselves. I want you to answer the question by yourself. Can we add and can we subtract them? If you can subtract them, if you cannot add them, why? If you can add them, why? Tell us the reason why we can add them. Tell us the reason why we cannot add them. So why we cannot subtract them rather. So we can add them, that's the correct answer, because they are of the same order. This is 3 by 3 and this is also 3 by 3. So we can add and we can subtract them. Then let's see how we add them together. So we have matrix H, matrix L. So we have H plus L, which should be written like this: H plus L. This is matrix H plus matrix L. So the same thing we did under the previous question, we are going to do the same thing here as well. That will be 3 plus 2, which is going to give us 5. 6 plus 5 will give us 11. 4 plus 5 will give us 9. 2 plus minus 3, that will give us minus 1, because plus times minus will give us a minus. So we have a 2 plus minus 3. So plus times minus will give us minus, so we have 2 minus 3 left, that will give us minus 1, which I believe you understand that. Then 1 plus 0, that will give us 1. 0 plus 4 will give us 4. Then minus 5 plus minus 4. Minus 5 plus minus 4. Minus 5 plus minus 4, what would that give us? Plus times minus will give us minus, so we have minus 5 minus 4, that give us minus 9. Do you understand that? 2 plus 8, that will give us 10. Then 3 plus 2, that will give us 5. So that's the addition of these two matrices will give us this matrix as well, which is also 3 by 3. Let's see the subtraction part of it. H minus L, matrix H minus matrix L. So we have this matrix H, which is this, minus matrix L, which is this. So how do we subtract? The same way we had, the same way we are going to subtract. So we have 3 minus 2, that give us 1. 6 minus 5, that give us 1. 4 minus 5, that give us minus 1. Also 2 minus minus 3. 2 minus minus 3. So minus times minus give us plus. So that means you have 2 plus 3, that give us 5. Then 1 minus 0, that give us 1. 0 minus 4, that will give us minus 4. Minus 5 minus minus 4. Minus 5 minus minus 4. Minus times minus give us plus, that give us minus 5 plus 4, that give us minus 1. Then 2 minus 8, that give us minus 6. Then 3 minus 2, that give us 1. So that is how we add and subtract matrices, knowing that the condition must be satisfied before we add and subtract. And if the condition is met, how do we add, how do we subtract? You add the element in the first row, first column will be added to the element in the first or second column, and you do the rest with others as well. And the same thing for subtraction. So let's see this last question as well. We are given 3 matrices. We have matrix A, matrix B, matrix C. We have to find A plus B, B plus C, A plus B plus C, A minus B, C minus A minus B plus C. So we want to simplify this as well. The question is, can we add these 3, can we add them together, or can we subtract them from one another? The answer is yes, because they are of the same order. All the 3 matrices are of the same order. This is 3 by 2, 3 by 2, 3 by 2 as well, so we can simplify this from there. So the first one is that you have to find A plus B. You are adding matrix A to matrix B. So matrix A plus B, that's what you are doing. And how do we do that? Of course, I already given you the answer here. I wanted to ask you to do that by yourself, but the answer is already here. Alright, let's see. We have 4 plus minus 5. What that give you? That give us minus 1, because plus times minus give us minus. So 4 minus 5 give us minus 1. 6 plus 8, that give us a 14. Minus 2 plus minus 4, that give us minus 6. 7 plus 3 will give us 10. 5 plus 2 will give us a 7. Minus 3 plus minus 7, that give us a minus 10. So when you add matrix A to matrix B, it will give us this. The next one is matrix B plus matrix C. So which is like this, matrix B, which is this, plus matrix C. So we add them together. You have minus 5 plus 0, that give us minus 5. 8 plus 6 will give us 14. Minus 4 plus minus 7, that give us minus 11. 3 plus 2 will give us a 5. 2 plus 5 will give us 7. Minus 7 plus 0 give us minus 7. So we have taken care of Roman figure 1, Roman figure 2. Then Roman figure 3, let's see that one in the next slide. Roman figure 3, we have A plus B plus C. So we have to add matrix A plus matrix B plus matrix C together. Let's see what it's going to give us as well. It's very simple. How do we do it? So 4 will be added to minus 5 to be added to 0 here. So we have a 4 plus minus 5 plus 0. That's how we add that one together. So let's add them together. We have a 4 plus minus 5 plus 0. So what would that give us? 4 plus minus 5 will give us a minus 1. plus 0, that give us a minus 1. 6 plus 8 will give us a 14, plus 6, that give us a 20. We have minus 2 plus minus 4, that will give us minus 6, plus minus 17, minus 7, that will give us a minus 13. We have a 7 plus 3, that will give us a 10, plus 2, that will give us a 12. We have a 5 plus 2, that will give us 7, plus 5, that will give us a 12. We have minus 3 plus 2, that will give us a, minus 3 plus minus 7 rather, that will give us a minus 10, plus 0, that will give us minus 10. So you see the same pattern you use when you are adding two matrices together. The same pattern you are going to use when you are adding 3 or more matrices together as well. So that is the solution to this addition of these 3 matrices. We know that it has a they have the same order, so we are going to get the answer is also going to give us the order of the matrices we had there together. So let's see the next one. We have a matrix A minus matrix B. Matrix A minus matrix B. So try to add these two try to subtract this matrix from one another and try to ignore this answer and see whether you're going to get the same answer we got here. So but if you do it right, you will get the same answer you're having here. So we have 4 minus 5, sorry, 4 minus minus 5 rather. So minus times 1 will give us plus, so we have 4 plus 5, that give us 9. 6 minus 8, that give us minus 2. Minus 2 minus minus 4, that will give us a plus 2. 7 minus 3 will give us a 4. Then 5 minus 2 will give us a 3. Then minus 3 minus minus 7, that will give us a 4. So that's the answer for matrix A minus matrix B. Then let's see matrix C minus matrix A. So this is matrix C minus this is matrix A. So if you subtract them as well, we have 0 minus 4, that give us a minus 4. 6 minus 6 is 0. Minus 7 minus minus 2, that will give us a minus 5. 2 minus 7 will give us a minus 5. 5 minus 5 will give us 0. Then 0 minus minus 3, that will give us a 3. Then the last one, we have a matrix A minus matrix B plus matrix C. So this is matrix A minus matrix B plus matrix C. So you can perform the two operation here and we should get this answer here. How do we do that? Let's see. 4 minus minus 5. So minus times minus will give us plus, so we have 4 plus 9, 4 plus 5, that give us 9. 9 plus 0, that give us a 9. Then we have 6 minus 8, that give us minus 2. Minus 2 plus 6, that will give us a 4. Then we have minus 2 minus minus 4, that will give us 2. 2 plus minus 7, that will give us a minus 5. Then also we have 7 minus 3, that give us a 4, plus 2, that give us a 6. 5 minus 2, that give us a 3. Then 3 plus 5, that give us a 8. Then minus 3 minus 7. Minus 3 minus minus 7, what would that give you? That give us 4. 4 plus 0 will give us a 4. So this depends on your ability to multiply minus and plus together and see which is the basic arithmetic we are doing here. So being able to know which one and which one are you going to add or subtract from one another after having known the condition of addition and subtraction of matrices. So that is how to add and subtract matrices from one another. Now if you understand the addition and subtraction of matrices, please you can attempt this question for your self-evaluation. Subtract this from one another, add this, subtract, this is subtraction as well. Then you are given question number 5, this 3 by 3 to which is matrix C, and this is matrix D. You have to evaluate A, that is which is C plus D. So add matrix C and D together. Whatever you get, call it matrix A. Then you are now to write down the element of A32, A23, A12. Then for here as well, you have to subtract C from D. Whatever you get, you name it matrix B, and can now write down B12, B23, and B32, which is which is cover everything we have talked about so far as far as matrix is concerned. Now the next thing we are going to be talking about is a multiplication of matrices. Multiplication of matrices, and this can be done in two ways. We can multiply a matrix by a number, which is called a scalar. So in this case, if we want to multiply matrices or multiply matrix, there are two ways in which it can be done. You can either multiply a particular matrix by with a number, which is a number is called scalar. So a scalar multiplied by a matrix. Now that is one part of multiplication of matrix. Another part is that you are multiplying two matrices together. So you're going to be treating how we can multiply a matrix by a scalar, and can also how we can multiply two matrices together as well. Those are the two things you are going to be doing under multiplication of matrices, and those are the only things you can see when it comes to multiplication of matrices. Now let's start with the first one, which is the multiplication of a matrix by a number, which is called scalar. Now let's see, to multiply a matrix by a number, which is called scalar, simply multiply each element of the matrix by the number. It's very simple. You are given a matrix now to multiply it by a particular number, so that means that number you are multiplying, using to multiply the matrix, will affect each element in the matrix. It will affect each element in the matrix. What are you trying to say in essence? For example, now let's say we are having that okay, this is a matrix now, which is a column matrix. You are having this column matrix to multiply by 5. So this 5 is multiplying this column matrix. So what do you think will happen? This 5 is a number which is a scalar, and this is a matrix. So this 5 want to multiply this matrix. What do you think will happen? This 5 will affect each element in this matrix. So you'll be having 5 times 7 and 5 times minus 2. So that will give us a 35 and a minus 10. So this is another matrix, another column matrix that is generated when you use this scalar to multiply this column matrix. It gives us another column matrix to get again. Let's see another one. We are having this row matrix to use this 7 to multiply this. So 7 is multiplying this column matrix. So also what will happen? This 7 will multiply each element in the column matrix. So you have 7 times minus 4, that gives us a minus 28. 7 times 2, that gives us 14. Then 7 times 0 give us 0. So which give us another column matrix. So another one is what you are seeing now. This 4 is multiplying this square matrix, this 2 by 2 matrix. So the same thing, 4 will multiply each of the element in the matrix. So we'll be having minus 20, 24, 12, and minus 16 as well. So that means it's going to give us this matrix as well. Do we understand this? So we have seen how we can use a scalar to multiply a matrix. That means each element of the that number will multiply each element in the matrix, and that's how we use a scalar, which is number, to multiply a matrix. Now let's see another thing we need to learn under this. We are still on using a scalar multiplying a matrix. Here you have matrix A and we have matrix B. You have to evaluate 2A minus 1 over 4B. So we know that this 2 is multiplying matrix A, which is this matrix A here, and this 1 over 4 is also multiplying matrix B. So what do? First of all, evaluate 2A, then evaluate 1 over 4B. Then whatever you now get, you are now to subtract them from one another, which is, we are talking about subtraction of matrices as well. So let's all simplify 2A. So if you simplify 2A, so that means you have 2 multiplying matrix A, and this is matrix A. So you'll be having 2 times 3, that give us 6. 2 times 2 will give us 4. 2 times 6 will give us 12. 2 times minus 4 will give us minus 8. 2 times minus 8 is minus 16. 2 times 5 is 10. So that means 2A will give us this matrix. Do we understand that? Let's simplify the 1 over 4B. So that means 1 over 4, which is also a number, we multiply matrix B. So we have 1 over 4 into this matrix B. So that means 1 over 4 will multiply 12, to multiply 15, to multiply minus 10, will multiply 0, multiply 5, will multiply minus 8 as well, which result to this matrix as well. So 1 over 4 times 12 will give us a 3, because 4 can go in 12, that's 3 times. The 1 over 4 times 15 will give us a 15 over 4. The 1 over 4 times minus 10, that will give us a minus 5 over 2, because 2 can go in 4, 2 can go in 10, so we have minus 5 over 2. 1 over 4 times 0, that will give us a 0. The 1 over 4 times 5 will give us a 5 over 4. The 1 over 4 times minus 8 will give us a minus 2. Do you understand that? So from there, now that we know this value of this, we know the value of this, so we can now subtract them. So therefore you'll be having 2a minus 1 over 4b will give us this matrix, which is for 2a, minus this matrix, which is for 1 over 4b. Then we can now subtract them. So can we subtract this matrix from this matrix? The answer is yes, because they are of the same order. This is 3 by 2, this is 3 by 2 as well. So then you now subtract them based on what you have learned so far on subtraction of matrices. So 6 minus 3 will give us a 3. 4 minus 15 over 4, which is this 4 minus 15 over 4. I don't want to simplify it straight. That's why I wrote it here. So if I want to do it on my own, I will have to just simplify straight by finding the LCM, and that will give us this answer. But let's continue. So we have 12 minus 5 over 2. So minus times minus will give us plus. So we have 12 plus 5 over 2, which is this. Then we have minus 8 minus 0. So that will give us a minus 8. We have minus 16 minus 5 over 4. That gives us minus 16 minus 5 over 4. Then we have 10 minus 2. Minus times minus will give us plus. So we have 10 plus 2. That gives us 12. Then you can now simplify this to further by finding the LCM and simplify. So LCM is 4. 4 times 4 gives us 16. So minus 16 over 5. So minus 16. Sorry, 4 times 4. 1 in 4 gives us 4. 4 times 4 is 16. Then minus 4 in 4 is 1. 1 times 15 will give us 15. So we have 16 minus 15 over 4. That gives us 1 over 4. Then here also we have 12 plus 5 over 2. Find the LCM as well and simplify that. That gives us 29 over 2. Minus 8 is minus 8. And minus 16 minus 5 over 4. Find the LCM also here and subtract the value. That gives us a minus 69 over 4. Then this is 12. So that means when you simplify this using these two matrices, using 2 to multiply a, using 1 over 4 to multiply b, and subtracting, it's going to give us this 3 by 2 matrices as well, which is the final answer. I want to believe you understand this. Alright, so let's see another question that can challenge us also. We have let 3 multiplying this matrix minus this matrix, which is in terms of a, b, c, d. That means we don't know the value of this element of this matrix, equals to 4 multiplying this matrix as well. We have to determine a, b, c, and d in this matrix. So of course you can see that the 3 is multiplying this matrix and minus this 2 by 2 matrix, which we don't know the value of a, b, c, d yet, and we know that 4 is multiplying this matrix as well. So what can you do? Just like when you know that when you have in your normal simple equation, you have x minus, sorry, you have 3 minus x is equals to 4. You know that you need to collect like time, so you can do that the same thing here. So what can we do? Having known that this is this, I can collect like time. I can bring this one here and this one comes here. So if you collect like times, what do you have? You'll be having 3 into this. This one comes here, you have minus 4 into this, equals to this one comes here, you have this matrix here. I believe you understand that. Good. So that means 3, we know that this 3 is a scalar, is going to multiply this matrix, and this 4 is a scalar, is going to multiply this matrix as well. So if you do that, you have 3 times 4, that gives us 12. 12, then 3 times minus 2 gives us minus 6. 3 times 6 is 18. 3 times 3 is 9. Minus 4 times minus 2 is minus 8. 4 times 5 is 20. 4 times 3 is 12. 4 times minus 2 is minus 8, equals to this matrix. Then of course we know that we need to subtract these two matrices, as you can see, because they can be subtracted. This is 2 by 2, this is 2 by 2 as well. Let's subtract them. You have 12 minus 8. That will give us 20, because minus times minus will give us plus. So that will give us 20. Then we have minus 6 minus 20, that gives us minus 26. 18 minus 12, that gives us 6. 9 minus 8, that will give us 17, equals to this matrix. So this matrix is 2 by 2, equals to 2 by 2. So there's an implication to that. It means that A will be equal to 20, B will be equal to 20 minus 26, C will be 6, and D will be equal to 17. So the left hand side is equal to the right hand side. So that will give us compare both sides. You have A to be 20, B is minus 26, C is 16, so C is 6, D is 17. So which is still on multiplication of a matrix by a scalar. So I want to believe you understand this as well. Now if you understand how to use a scalar, which is a number, to multiply a matrix, then try to evaluate yourself using this question on the screen right now. We are given matrix A, matrix B, matrix C. Find 5A, 3B, 2/3C, then the last one half of B plus 1/3 of C. So simplify this. Then here you have matrix S, matrix Y, and matrix Z. You have to calculate 2x minus 4y plus 2/3z. So simplify this as well and leave your answer in the comment section of this video, or at the end of this video I'm going to leave my email address where you can snap your answer and share it with me on using my email, and I will respond to your answer via your email as well, so as to help you evaluate, check whether you are right or wrong. Now that we understand how to use a scalar to multiply a fraction, a matrix, let's see how we can multiply two matrices together. So we are going to be talking about multiplication of two matrices now. In this case, we are not multiplying a matrix by a scalar. No, we are multiplying two matrices now, two different matrices or two same matrices together. I want to multiply them out. That's what we are going to be doing this. So also a condition must be satisfied as well. So before I can multiply two or more matrices, a condition must be met. Just like under addition and subtraction of matrices, before we can add or subtract matrices, there's a condition that we said that must be satisfied. Also in multiplication of matrices as well, there's a condition that must be satisfied before we multiply them out. And what is the condition? The number of elements of each row of the first matrix must be equal to the number of elements of each column of the second matrix. Do we understand that at all? Let me come again. The number of elements of each row of the first matrix must be equal to the number of elements of each column of the second matrix. So don't forget, we are having two matrices that we want to multiply together. So the first matrix, the number of elements in the row or in each row must be equals to the number of elements in the column or in each column of the second matrix. That's the condition. Please, you must know this condition now, because there are some cases whereby two matrices will not be able to multiply themselves, but if you don't remember this condition, you go ahead and multiply them and you just waste your time. I do test my students on this as well. So there are some questions that there are some questions that it is not possible for you to multiply them together because those questions failed to, it did not satisfy this condition. So in that case, you don't need to multiply out at all. But some students will have forgotten that in multiplication of matrices, the number of elements of each row of the first matrix must be equal to the number of elements of each column of the second matrix. Let's see that. Now let's look at this matrix. Now we have this matrix and this matrix. Now this is a row matrix and this is a column matrix. So that means this matrix has one row, it has one column. That's not what the condition is saying. No, what the condition is saying that this first matrix, how many elements are in the row? It has one row and it has how many elements in it? 2 elements. Now this is the second matrix. This one has how many rows? 1, 2 rows. But we are not using the row now in this second matrix. You are using column. You are using the column. So it has one column. But how many elements do we have in the column? 2 elements. 1 and 2. So this is the column. It has 2 elements in the column for the second matrix. For the first matrix, it has 2 elements in the row. So 2 elements in the row, 2 elements in the column. So that means we can multiply these matrices out. So it is possible. Can we multiply them out? Yes, we can multiply them out because it satisfies this condition. The element in the row, which is 2 elements in the row, must be equal to the number of elements in the column, in each column. So this one just has only one column now, but number of elements there is 2 in the column here. Number of elements in the row here is what? 2. So that means they can multiply out. Let's see another example. Look at this question here. This is another matrix. How many row does he have? He has just one row. Good. But that's not what you are using. You are using the number of elements in the row. How many elements do we have in this row? We are having 3 elements. Look at the second matrix. How many elements do we have in this column? It has 3 elements in the column. So can we multiply them out? Yes, we can multiply them out. 3 elements in the row, 3 elements in the column. So that means they can be multiplied out. Do you understand that? Let's see another example. Now look at this example as well. This element, look at the row of this element, this matrix as well. Sorry, the row of this matrix has how many elements? It has 3 elements in it. 3 elements in this row, which is 1, 2, 3. So 3 elements in this row. Do we understand that? Then how many elements do we have in this column? 2 elements. Can they multiply out? No, it's impossible. 3 elements in the row, 2 elements in the column, so it's impossible we multiply them out. Let's see another example. Can we multiply these 2 matrices? Can we multiply them out? Check yourself before we decide. Before I tell you the answer. Can we multiply this matrix by this matrix? The answer is yes. We can multiply them out. Because look at this row. How many elements do we have here? 2 elements. Look at this column. How many elements do you have there? 2 elements. Look at this row as well. How many elements do you have there? 2 elements. How many do you have in this column? 2 elements. So that means we can multiply them out. Yes, they can be multiplied. 2 elements in the row, 2 elements in the column. So the condition is met. Let's see another one. Can we multiply these 2 matrices? Yes or no? Yes, they can be multiplied. This row has 2 elements. This column has 2 elements. This row has 2 elements. This column has 2 elements as well. So same number in the row, same number in the column. So they can be multiplied as well. Do you understand that? Let's see another one. Look at these 2 matrices. Can we multiply them out? Can we multiply them out? Yes, the answer is yes. The element in the row here is 2. The element in the column is 2. The element in the column is also 2. The element in the row here is also 2. The element in the column is 2. The element in the column is 2. So that means we can multiply them out. Do we get that? Good. So the number of elements in the row must be equal to the number of elements in the column of the second matrix. The number of elements in the row must be equal to the number of elements in the column of the second matrix as well. So we can multiply them out. Let's see another question. Can we multiply these 2 matrices as well? I want you to check very well and tell me the answer. Can we multiply this matrix by this matrix? Yes or no? Okay, the answer is yes, we can multiply them. The first row here has 3 elements, and the column here also has 3 elements. 3 elements in the column here, 3 elements in the column here, 3 elements in the column here. So number of elements in the column is same as number of elements in the row same as number of elements in the column. So look at this row as well. It has 3 elements. So which means that all this one also has 3 elements as well in the column. So that means they can multiply as well. So the number of elements in the row of the first matrix must be equal to the number of elements in the column of the second matrix. So we can multiply them out. Now let's see another one. Can we multiply these 2 matrices? Yes or no? Can we multiply them out based on what you have learned so far? The answer is capital no. We cannot multiply them out, because look at this first matrix. The element in the row here is 2. Look at the second matrix. The element in the column here is what? 3. So they can't multiply. The element in the row here is 2. The element in the column here is also what? 2. So you can't. So the element in the column is 3 rather. So they can't multiply. So the answer is No. So you don't forget the condition for matrix multiplication of matrices. Don't forget that the number of elements in each row of the first matrix must be equal to the number of elements in each column of the second matrix. So if that condition is satisfied, then you go ahead and multiply out. But if the condition is not satisfied or not met, then don't bother to multiply. It is impossible. Good. Now that we know the condition for multiplication of matrices, then how do we multiply matrices out? How do we multiply them out? So let's see how we multiply matrices in this section. Now let's see the first question here. Now we have the first question. You got to multiply this matrix by this matrix. Ask yourself, can they multiply themselves? Before you go ahead to multiply, can they multiply? Is the condition for multiplication satisfied? The answer is yes, they can multiply. It has 2 elements in the row, it has 2 elements in the column, so that means they can multiply. Then how do we multiply? The row here will multiply the column here. That's the way we multiply. Row of the first matrix, the row of the first matrix here will multiply the column of the second matrix here. So this row will multiply the column, and that's why I help you to put this arrow to show how to multiply 2 matrices. The row of the first matrix will multiply the column of the second matrix. The row of the first matrix will multiply the second row, will multiply the column of the second matrix, and that is what these 2 arrows are representing. A row, then column. Do you understand that? That's how we multiply out. And when you multiply 2 matrices out, it's going to give us another matrix, but it may not be the order of these matrices we are having here. And I'm going to teach you how to get the order of the matrix before you even multiply them out. Let's see how we multiply. So the row will multiply the column. So that means these 2 will multiply 4 plus 3 will multiply 7. 2 will multiply 4, 3 will multiply 7. Don't forget that the row is multiplying the column here. 2 multiply 4, 3 will multiply 7. So we have 2 times 4 plus 3 times 7. What would that give you? So 2 times 4 plus 3 times 7. That should give us 8 plus 21. And then that should give us what? 29, which is another matrix given to us, which is as 1 row, 1 column. The matrix has 1 row, 1 column. So that means when I multiply this matrix by this matrix, it gives me this matrix we are having here. Let's see another question. Can we multiply this matrix by this matrix? That's the question we need to ask ourselves. Yes or no. If it is impossible, then you write it is impossible. But if it is possible, then you go ahead and multiply out. Is the condition for multiplication of matrices satisfied? The answer is yes. 3 elements in the row, 3 elements in the column, so that means they can multiply out. Then how do we multiply? The row will multiply the column. The row of the first matrix will multiply this column of the second matrix. And how do we do that? 2 will multiply 1 plus 0 will multiply 2 plus 1 will multiply minus 1. Do you understand that? 2 will multiply 1, 0 will multiply the 2 at the middle, 1 will multiply minus 1. So if you do that, we have 2 times 1 plus 0 times 2 plus 1 times minus 1. And if you simplify that, that will give us 2 plus 0 minus 1 if you multiply out and add. So 2 plus 0 is 2 minus 1, that will give us a minus 1 as well. So that will give us 1 rather. So when I multiply this matrix by this matrix, it gives me what? This matrix, which is 1. It means it has 1 row and 1 column as well. Let's see another question. Look at this matrix as well. Can we multiply them out? We have to multiply this by this. Can we multiply them out? Yes or no? Is the condition satisfied? Yes, the condition is satisfied. We have 2 elements in the row here, 2 elements in the column here. So 2 elements in the row, 2 elements in the column, so they can multiply. Then how do we multiply? This row will multiply this column first, Then this second row also we have multiply this column again. So we have two rows here, one row, two row, second row. So this first row, first of all, multiply this first column. Then another again, this second row also will go and multiply this second this column again as well. That's how you multiply. So the row will multiply the column, second row also will go and multiply the column. Now let's go with this first row. First row will multiply this column, so we have 6 times 1 plus 1 times 3. Do we understand that? Then the second row also will go 7 times 1 plus 3 times 3. Do we understand that? So let's see that in action. So we have 6 times 1 plus 1 times 3. The row will multiply the column. 6 times 1 plus 1 times 3. That's for the first one here. Then the next one here, we have a 7 times 1 plus 3 times 3, which is this. Because the first row will multiply this column, will give us this answer. Then the second row also will multiply this column, will give us this second answer as well. Do we grab that? So if you simplify that further, we have 6 times 1, that gives us 6, plus 1 times 3, that gives us 3. So we have a 6 plus 3 for the first row here. Then 7 times 1 will give us a 7 as well, plus 3 times 3 give us a 9. So we have 7 plus 9 as well. If you simplify further, we have a 6 plus 3 is 9, 7 plus 9 is a 16. So when I multiply this matrix by this matrix, it gives me this column matrix, which is a 9 and 16. Do we grab that? Let's see another example. We want to multiply this matrix by this matrix. Can they multiply? Yes or no? The answer is yes. The number of elements in the row here is 2. Number of elements in the column here is 2. Number of elements in the column here is also 2. So that means they can multiply. So the number of elements in the row is equal to number of elements in the column. Number of elements in the row is also equal to number of elements in the column here. So that means they can multiply. Then how do we multiply as well? The row will multiply this first column. Then this row also will multiply the second column as well. Do we understand that? So this one has one row. It will multiply these two columns. Then if you do that, how do we go about that? 3 will multiply 5. Then 0 will multiply 0, 1. Again 3 will multiply 7, 0 will multiply 1 again. Do we understand that? You should know the difference between this one and this one. So this one has 2 rows, 1 column, 1 row, 2 column, but the condition is satisfied. Then the question is, how do we multiply them out? These 2 rows will multiply, this row will multiply here, this row will multiply this here as well. Then this row will multiply this, it will also multiply this. Do we understand that? And let's see how we multiply out. 3 will multiply 5, that will give us a 3 times 5, plus 0 will multiply 0. So the row has multiplied the column, that will give us this. Then this row again will multiply this column, so we have 3 times 7, 3 times 7 plus 0 times 1, that gives us 0 times 1 here. If you simplify that further, we have 4 times 3 times 4, 5 is 15 plus 0, so that gives us 15 plus 0. Then we have a 3 times 7, that is 21, plus 0 times 1, that gives us 0. You simplify that, give us a 15 and 1 and 21, which is also another column matrix. Do you understand that? Good. Then let's see another question. We are having this 2 by 2 matrix multiplied by this 2 by 2 matrix. Can they multiply themselves, or can they multiply each other rather? Can they multiply each other? The question is yes. 2 elements in the row, 2 elements in the column, so that means they can multiply. So this row will multiply this column 1. This row will also multiply this column. Do you understand that? Then again, this row will multiply this column. This row will also multiply this column. That's how you multiply them out. So this row will multiply this column. This row will multiply this column. Then this row will multiply this column. This row will also multiply this column as well. So row will multiply the column. That's how what this arrow is telling us. Do we understand that? Let's multiply them out. So if we multiply them out, you have a 3 times 0. This first row is multiplying the first column. So 3 times 0, sorry, 1 times 3 rather, don't mind me. 1 times 3 plus 0 times 0, which is for this. Then please don't join this one and this, don't join this one and this one together. So this row multiply this column, so we have this. Then this row also will multiply this column, so we have 2 times 1, that gives us this one. Then plus 0 times minus 5, which is this. So that means this row multiply this column, we have this answer. Then this row multiply this column, we have this answer as well. So let's go for the second row here. 1 times 3 will give us this. Then 3 times 0 will give us this. Then also 1 times 2 we have this, plus 3 times minus 5 we have this as well. So that means this row also multiply this column. This row will also multiply this column as well. That will give us this as well. From there you can now simplify further. 1 times 3 give us 3 plus 0. So that should give us a 3 plus 0 here. Then 1 times 2 is 2. Then 0 times minus 5. Error. So 0 times minus 5 is this is 0, not minus 5. That's a typographical error. Please correct that. 0 times minus 5 will give us a 0, not minus 5. So that is it's oversight, an oversight. 1 times 2 is 2, plus 0 times minus 5 is 0, yeah, not minus 5. So correct that in your, when you are writing your own notes. So 2 that will give us a 2 minus 0 here. Then here you have a 1 times 3, that gives us a 3, plus 3 times 0 is 0. Then 1 times 2 is 2, plus 3 times minus 5 will give us a minus 15. So you have 2 minus 15 there. So that means your answer will becomes 3 plus 0 is 3. Then 2 minus 0 will give us 2 here. This one is 2. The answer is 2, not minus 5. So not minus 3. This is 2 minus 0. So you have 2. Then 3 plus 0 is 3. 2 minus 15 is what? Minus 13. So when you multiply this matrix by this matrix, which is this, then you can now simplify further to give us 3 minus 13. Do we understand that? Now let's see this another one out. Let's multiply this matrix by this matrix. Can we multiply them out? Is the condition satisfied? Yes, the condition is satisfied. This element here, the row here has 3 elements. The column here has 3 elements. So the row here also have 3 elements. The column also, each of them has 3 elements. So that means the row here, how do we multiply them out? How do we multiply them out? The column here will multiply this, sorry, the row here will multiply this column. This row also will multiply this column. This row also will multiply this column as well. Then the second row will now go and multiply this column. This row also will multiply this column. This row also will multiply this column. That's how you multiply them out. Do we grab that? If you understand that, let's multiply them out. So we have the row multiplying the column. Then how do we do that? How do we do that? Now let's see. So the row will multiply, this first row will multiply the first column here. So you have a 1 times 1, that gives us this, plus 3 times 5, plus 2 times 8, which is this. So that means this row has multiplied this column. Then this row also again will go and to multiply this column. So you have a 1 times 2, 3 times 7, 2 times 0. Then this row again will go and multiply the third column. So we have 1 times 4, which is this, 3 times 2, which is this, plus 2 times 1, which is this. So technically this row has multiplied these 3 columns. Then the second row of this first matrix will go again and multiply these 3 columns as well. So we have a 1 times 1, which is this, 2 times 5, plus 6 times 8, which is this. Then this row again will multiply the second column. So we have 1 times 2, 2 times 7, 6 times 0. Then also this row will go again and multiply the third column. So we have 1 times 4, 2 times 2, then 6 times 1, which is this. So we have seen now we multiply out 2 matrices now. The row will always multiply the column. The row will always multiply the column, which is this we are having here. Now we can now simplify further. 1 times 1 is 1, plus 15 plus 16, which is what you're having here. We have 1 times 2 is 2, plus 21 plus 0. Then we have 1 times 4 is 4, plus 6 plus 2. Also here we have 1 times 1, which is 1, plus 2 times 5, which is 10, plus 6 times 8 is 48. 1 times 2 is 2, plus 2 times 7 is 14, 6 times 0 is 0. Then 1 times 4 is 4, plus 2 times 2, which is 4, times 6 times 1, which is 6. Then you can now add this together, add this together, add this together, add this together, add this together. So if you add, you'll be having 1 plus 15 plus 16 is 32, 2 plus 21 plus 0 is 23, 4 plus 6 plus 2 is 12, 1 plus 10 plus 48 is 58, 2 plus 14 plus 0 is 16, 4 plus 4 plus 6 is 14. So when we multiply this matrix by this matrix, it gives us this matrix. So let's try to multiply this matrix out and see what we get. The question is, can they multiply themselves, or so can they multiply each other? I want you to answer that question. So what is your conclusion based on the condition for multiplication of matrices? Can these two matrices multiply each other? No. The answer is no, they can't multiply each other, because this row has 2 elements, this column has 3 elements. So each column here has 3 elements, but each row here has 2 elements, so that means they cannot multiply. So the row multiplying the column, it is impossible, because the number of elements in each row of the first matrix is not equal to the number of elements in each column of the second matrix. So you can be given this question in an examination to simplify, and you will see some student writing solution, meanwhile it does not have any solution based on the understanding of the condition for multiplication of the matrices. So these cannot multiply themselves. Now let's see another question. Now here question, we have a matrix A and matrix B. You have to find AB. So we have a matrix A and matrix B. You have to find AB. So which literally means that you have to use matrix A to multiply matrix B. So the question is, can this matrix multiply this matrix? That's the question. Can they multiply them each other? Yes, the answer is yes, they can multiply. The row here has 3 elements, the column has 3 elements. So each row here has 3 elements, each column here has 3 elements, so they can multiply. So let's see how we multiply them out. Now you have a matrix A multiplied by matrix B. So we have this is matrix A, this is matrix B. So let's see how we multiply them out. Of course, the row will multiply column always. So row multiply column. Now this arrow is not supposed to be there when you are doing your own, but if you put it there, you are not going to be penalized. I'm putting it so that you help us in multiplying out that the row of the first matrix will always multiply the column of the second matrix. So, and how do we multiply this out? Now this first row we multiply this column, multiply this column, multiply this column. Also this second row also will go, it will multiply this first column, second column, third column. Then this third row will also go, multiply this first column, second column, and the third column. So that's how we go about this one. Now let's see that in action. So if you multiply that out, it's going to give us something like this. Very simple, but it could be difficult if your care is not taken. Now let's go. The first row, multiply this first column. So that means you have 1 times 3. We have here plus 4 times 4 plus minus 3 times 2, which is what you're having here. Then this row also will go, this row also will go and multiply the second column. So you have 1 times minus 1, which is this, 4 times 1, which is this, minus 3 times minus 3, that will give, this is this. Then this row also will go and multiply the third column. So you have 1 times 2, which is this, then 4 times minus 3, which is this, plus minus 3 times 5, which is what you're having here. So that means this first row has multiplied this 3 column. Now the second row of this first matrix will go again and multiply the 3 column. So you have a 2 times 3, which is this, minus 3 times 4, which is this, 4 times 2, which is this. Then also 2 times minus 1, which is this, minus 3 times 1, which is this, 4 times minus 3, which is this. Don't forget we are adding them together, we have plus plus in between. Then this also will go and multiply this. We have 2 times 2, which is this. We have minus 3 times minus 3, which is what we are having here, plus 4 times 5, which is this as well. Then the third row also will go and multiply the 3 columns. So we have 5 times 3, which is this, plus 0 times 4, which is this. Then we have 1 times 2, which is this. Then this row will also multiply the second column. 5 times minus 1, we have this. 0 times 1, we have this. 1 times minus 3, we have this as well, plus this. Then 5 times 2, which is this, plus 0 times minus 3, which is this, plus 1 times 5, which is this. So we have been able to multiply out the rows, have been able to multiply the columns here now. So we can now simplify further by add and multiply and add. So let's go ahead. 1 times 3 give us a 3, plus 4 times 4 give us 16, plus minus 3 times 2 give us minus 6. Then minus times plus will give us a minus, so we have minus 6 here. Then also we have 1 times minus 1 will give us a minus 1, plus 4 times 1 is 4, plus minus 3 times minus 3 give us plus 9. 1 times 2 will give us a 2, 4 times minus 3 give us a minus 12, minus 3 times 5 will give us minus 15. So 2 times 3 give us 6, minus 3 times 4 give us minus 12, 4 times 2 give us 8 here. So that then 2 times minus 1 give us minus 2, minus 3 times 1 give us minus 3, 4 times minus 3 give us a minus 12. Then 2 times 2 will give us 4 here. Then also minus 3 times minus 3 will give us a 9. Then 4 times 5 will give us a 20. Then 5 times 3 here will give us 15, plus 0 times 4 give us 0, plus 1 times 2 give us 2. Then 5 times minus 1 will give us a minus 5, 0 times 1 will give us a 0. Then plus 1 times minus 3 give us minus 3. Also 5 times 2 will give us 10, plus 0 times minus 3 give us a 0, plus 1 times 5 will give us a 5. Then from there, if you simplify this further, 3 plus 16 minus 6 will give us a 13, minus 1 plus 4 plus 9 will give us a 12. Simplify this will give us minus 25. Simplify this 2. Simplify this, that will give us a minus 17. Simplify this, that will give us a 33. Simplify this, that will give us 17. Simplify this, that will give us a minus 8. Simplify this, that will give us a 15. So that's solution to that question when you multiply them out. Now let's try to simplify this as well. We have a matrix B and matrix C. You have to find BC. So that means matrix B is multiplying matrix C. So the question is, can they multiply out? Yes, they can multiply, because this is 3 by 3, 3 by 3. So this has 3 elements in the first row, 3 elements in the column here. So, and that means they are equal. So that means they can multiply. So let's see how we multiply them out. The row will multiply the column here. So each of the row here will go and multiply each of the column here as well, just like we did in previous question. So let's see how we multiply out as well. So this row will multiply this first column. It will give us this one. This same row will multiply this second column. That will give us this answer we are having here. Then this row will multiply this third column. That's what we are having here as well. Then also the second row will go and multiply this first column. That give us this answer to this place. This second row will go and multiply this second column. We give us from here to here. This also will go and multiply this. We have this. Then this third row here will multiply this first column here. We have this. Then this third row will multiply the second column here. We have this. And this also will multiply this. We have this as well. Then you can now simplify further. Then that should, if you simplify each of these, 3 times 1 will give us 3, minus 1 times 4 give us minus 4, then 2 times 3 give us 6. So that give us this. Simplify this as well. We have this. Simplify this. We have this as well. Simplify this. We have this. Simplify this. We have this. simplify this, we have this as well. Then simplify this, we have from here to here. Simplify this, you have this, and simplify this, we have this as well, which if you simplify further, so that give us 5, 13 minus 3 will give us a minus 1. We have 7, we have 5, we have 5, we have 17, and we have minus 7. So which is the value of BC. And the another thing I want to understand here is that those, you can see that whatsoever you are having here is representing first row, first column. So don't go and add it to this one here, please. And whatsoever you are having here is representing the first row, second column. So don't go and add it to this. So whatever you are having here is representing this first row, second column, and so on as well. So don't go and join them together, because we'll go and write plus. Don't go and write plus here. Also don't go and join them together. Do you understand what I'm trying to say? Now if you understand how to multiply matrices together, then attempt this question on the screen right now. You have matrix C and matrix D. You have to find CD, you have to find DC, you have to find D square. That means this matrix square of it, that is in two places. This multiplied by this again, so the C square, that will be this matrix in two places as well, multiply together. So check if they can multiply before you go ahead and multiply. If they cannot multiply, then you write it is impossible. Then number 2, we have matrix P and matrix Q. We have to show that PQ is not equal to QP. So for the PQ, we have matrix P times matrix Q. Get the answer for that. Then for QP, that means matrix Q is coming before matrix P. So you have Q multiplied by this P. Then multiply it as well. See what you are going to get. So if your answers are different, then that means you have been able to show that this is not equal to this. Then also we have matrix X and Y. You have to find X times Y. So that is an on multiplication of matrices out, and they send your answers to me, and I will help you to verify whether you are right or wrong. So that end our discussion on multiplication of matrices. Now the next thing we want to talk about is how to transpose matrix. Transpose of a matrix. How do we transpose matrix, or what is the meaning of a transpose of matrix? Now that we understand how to multiply matrices out, how do we transpose matrix? Now the word transpose means change. Transpose of a matrix means change the rows of that matrix to column, or you change the column to row. That's simply the meaning of transpose of a matrix. Change either the row to column, or I change the column to the row. So that is how to transpose a matrix. So if I change the row to column and another person change the column to row, we are going to get the same answer. But I'm just telling you how to transpose a matrix is by changing either the row to column, or I change the column to row. So to transpose a matrix means to interchange its row with its column. So if the given matrix is B, sorry for that English, then the transpose is denoted by B raised to power T. That is how do we represent the transpose of a matrix? By writing the name of that matrix and you put raised to power T. So this means that you are finding the transpose of matrix what B. You are finding the transpose of matrix what B. So that's what it means. Then let's see some examples. Now in this case we are having matrix A, which is having this matrix. I have to find the A transpose. So that means I can change this row to column, this row to column, or I change this column to row, I change this column to row. So anyone that wants to do, we'll still get the same answer. So in this case, let's see, we change this column to row. So this is row here. I change it to column, so you have 2. Then this 4 will come down here. Then this row again, I will change it to column, so that minus 9 will come here and 3 will be here. So that means you have been able to transpose that matrix like that. Or if I want to change this column to row, what will it give me? So if I change this column to row as well, what will it give me? 2 will be here, this one will come here, minus 9, then 4 will come here, then this 3. So I've changed that column also to row, which is still give me the same answer. So anytime you are transposing a matrix, you can either change the row to column or change column to row. Anyone you want to do, it will give you the same answer. Let's see another question. We have this matrix P. You have to find P transpose. So I can take this column here, which is this column, I can change it to row. So I have 19, 17 and 19. Then this second column I will change it to row also. I have minus 3, 15 and 26. So if you do that, that means what do we having? We have 19, 17, then 19. Then this second column we have a minus 3, 15, then 26. So we have been able to transpose that matrix P like that. Do you understand that? Let's see another one. Okay, we are given this matrix X. You have to find X transpose. So I can change this row to column, I can change this row to column, this row to column, or I can change this column to row, this column to row, then this column to row as well. Anyone I want to do, you get the same answer. So let's change this column to row. We have 3, 2 and 6. This column to row we have 7, 3 and 0. This column to row we have minus 4, 5 and 1. So that will give us what you have in here on the screen right now. So we have been able to transpose that matrix like that. Alright, let's see this last question. Yeah, we have to transpose this matrix as well to okay, we have to transpose it as well. So I can change this column to row. So I have 5, 1, 1. This column to row minus 3, 0 and 2. This column to row I have 2, 3 and 5. This column to row I will have a 6, 2 and minus 1. This is going to give us something like this. You have 5, 1, 1 minus 3, 0, 2, 2, 3, 5, 6, 2 minus 1. So like that we have been able to transpose that matrix like that, as simple as that. So let's look at this question again. We are given matrix G and matrix H. You have to find G transpose, H transpose. You have to find G multiplied by H, then we have to transpose our answer. After multiplying matrix G by matrix H, then you transpose it. So you can okay, I've already given you the answer for the first one. Now for G transpose, of course this is the column, I can change it to row. So you have 3, 4. This column as well I have 2, 1 to row, and this column as I will change to row we have 5, 7. So for matrix H to transpose, so we have a 6, 5, 0. If you change this column to row, we have 6, 5, 0. Then this column to row, we have minus 3, 3, minus 1, 3, 3 and 1. So transpose G matrix H. You have the column here become the rows, then the second column here will become the row here. So it gives you like this. Then to solve the question for C here, the first is to forward multiply matrix G by H. Whatever you now get, you now transpose it. So let's first of all find the G multiplied by H first. So matrix G to multiply matrix H, the question is, can they multiply? Is the condition for multiplication of matrix satisfied? Yes, it is satisfied. We have 3 elements in the row, 3 elements in the column, so that means they can multiply. So if you multiply them out, let's go about it. So the row will multiply the column. So 6 times 3 plus 2 times 5 plus 5 times 0. Then the row will also multiply the column here. You have a 3 times minus 1, 2 times 3 plus 5 times 2. So that means second row also will go. Second row will multiply the column here. That will give us this. Second row here will also multiply the column here. That will give us this as well. So if you simplify that further, this time they give us 18 plus 10 plus 0. So that will give us 28. The minus 3 plus 6 plus 10. That will give us a 13. We have 24 plus 5 plus 0. That will give us 29. Minus 4 plus 3 plus 14, that gives us 13. So now we have the value of G times H. Now we are now to transpose whatever we get here. So that means this column will become the row, this column will also become the row. So GH transpose will give us a 28, 29, 13, 13. So now we have seen how we can transpose any matrix now by changing the column to the row, or change the row to the column, anyone you want to do. So if you understand how to transpose matrix now, you can attempt this question on the screen right now. We have to transpose matrix K, matrix L. You have to find KL, then whatever you get, transpose it as well. You have a matrix A and matrix B here. You have to transpose matrix A, matrix B, find AB, which is A times B, then whatever you get, you transpose it as well. So you can send your answers to me so as to help you on the check whether you are right or wrong. So having understood how to transpose a matrix, then the next thing on our agenda is to find the determinant of 2 by 2 matrices. Determinant of 2 by 2 matrices, that's the next thing on our agenda. How do we find the determinant of 2 by 2 matrices? Now before we go to determinant of 2 by 2 matrices, the first thing you need to know is that when you are finding determinant, we use 2 straight lines to represent determinant. You know, in all the matrices that we have been talking about, since we have been using curve brackets to enclose the element of a particular matrix. But when it comes to determinant, if they want you to find the determinant of a matrix, they will not use the curve bracket. They will use 2 straight lines to enclose the elements, and those 2 straight lines means determinants. So what I'm trying to say in essence is that if a matrix is enclosed by these 2 straight lines instead of a curve bracket, it simply means that you have to find the determinant of the matrix. So if I use these 2 straight lines instead of curve bracket to enclose the element of a matrix, it means that 2 straight lines represent determinants. It means you have to find the determinant of the matrix. So you can see as an example now, I have this matrix. Now instead of using curve bracket, I use these 2 straight lines. It simply means find the determinant of this 2 by 2 matrix. Another thing you need to know is that also if the name of a matrix is enclosed in these 2 straight lines, it simply means calculate the determinant of the matrix. So if I give a name to a matrix now, and I say find, and I use these 2 straight lines, and I write the name of the matrix, it means that you have to find the determinant of that matrix. And we know that these 2 straight lines means another thing in mathematics. It means modulus in another topic, but in the matrix now it means determinants in matrix. Do you understand that now? So if I write A now, I write the name of a matrix and I put this 2 straight line, it means that you have to find the determinant of that particular matrix A. Do we understand that now? So this 2 line, anytime you see it in matrix, it represents determinants. Okay, how do we find the determinant of a matrix? Now, of course, we are talking about determinant of 2 by 2 matrix. Of course, this matrix is a 2 by 2 matrix. And another thing you need to know is that we can only find determinant of square matrix. That means we can only find 2 by 2 or 3 by 3. So let's see how you can find the determinant of any 2 by 2 matrix. So this is an example of a 2 by 2 matrix. How do we find the determinant of it? You can see that I'm having these 2 straight lines here now that is enclosing this matrix. So how do we do it? This matrix has 2 diagonals. This 2 by 2 matrix has 2 diagonals. This is the leading diagonal and this is the second diagonal. So we have the first diagonal, which is the leading diagonal, and this is the second diagonal. So the leading one is this, then the second one is this as well. So what do? You have to cross multiply this leading diagonal minus the cross multiplication of this. You multiply this second diagonal as well. So you multiply this leading diagonal minus multiply the second diagonal as well. So that will give us the determinant. So that means this will give us A times D, which is this, minus B times C. So A times D will give us AD minus BC. So that's how to find the determinant of any 2 by 2 matrix. This is the leading diagonal. You multiply them out, and the second diagonal you multiply that as well. So that is this times this. A times D will give us AD, then B times C will give us a BC. But you need to subtract this the multiplication of this minus the multiplication of this. So if you understand that, let's try this matrix. We have matrix M. You have to find determinant of matrix M. So we are given matrix M, so we have to find its determinant. How do we go about it? Of course, I've already given a clue here. This is the leading diagonal and this is the second diagonal. So this diagonal needs to be multiplied minus this second diagonal. So if you do that, what do we have? It means that the determinant of matrix M is equal to these two straight lines. Then you put the element inside, then cross multiply. These 2 multiply 8 minus 4 multiplies 3. So that will give us okay, I'm just showing you how you do it. This will multiply this will multiply this, and you subtract them. So this is the leading diagonal and this is the second diagonal. So this lead diagonal minus the second diagonal, when you cross multiply, then what do? So 2 times 8 will give us this, minus 4 times 3. So that will give us 16 minus 12, and that will give us 4. So that means the determinant of this matrix M is 4. Let's see another question. Now we are given matrix N, which is also 2 by 2. We have to find the determinant of matrix N. So of course it's very simple as well. This will multiply this minus this will multiply this. So that will give us a minus 5 times 2 minus 1 times 4. So that will give us a minus 5 times 2 minus open bracket minus 1 times 4. And you know the reason why I'm putting this one in bracket, because we are having minus here again, so I cannot write minus minus, so one of them will need to be in bracket. So we have a minus 10 minus 1 times 4 give us minus 4. The minus times 1 will give us a plus, so you have minus 10 plus 4, and that will give us minus 6. So that means the determinant of matrix N is minus 6, which I believe you understand that. So let's see another question. Find the determinant of matrix A if we are given matrix A to be this matrix having an element of minus 2, 3, minus 6, and 9. You have to find the determinant of this matrix. So it is stated, they didn't use these 2 straight lines, but they said it in the question. Find the determinant of matrix A. So it means that we have matrix A enclosed by these 2 straight lines equals to this straight line. You put the element inside. Then how do we go about this? This leading diagonal minus the second diagonal subtracted from one another. So that should give us a minus 2 times 9 minus 3 times minus 6, which I believe you understand that. That will give us a minus 18 plus 18, and that should give us 0. So which is another type of matrix that we did not discuss at the beginning. So we have another type of matrix that we did not discuss under the types of matrix, and that is a singular matrix. A singular matrix is a matrix that has its determinant to be equal to what? 0. So any matrix that its determinant is equal to 0 is called a singular matrix. And the reason why I did not give you under the type of matrix is because we did not know what is determinant of matrix. So now that we understand the determinant of matrix, so when you find the determinant of a matrix and it gives you 0, that means that matrix is called a singular matrix. So this is another type of matrix that we must know, a singular matrix. That when I find the determinant of a matrix and the answer gives me 0, that means that matrix is a singular what? Matrix. Alright, let's see more question. So we have a matrix A. So we have to find matrix A. So we are giving matrix A, you have to find the determinant of matrix A. Then B, you have to find the determinant of A transpose. So that is, you have to transpose the matrix, then find its determinant as well. So it's very simple as well. For the first one, determinant of matrix A, you have to find the determinant of this matrix. So cross multiply, then you subtract. So we have 3 times minus 7, which is this, then minus 4 times minus 5. So that should give us a minus 21 plus 20, and that will give us a minus 1. Then for the second one, B, you need to find A transpose first. So if you find A transpose, that means the column become the row. So you have a 3, then minus 5, which is this, then you have a 4 minus 7, which is this. So we have been able to transpose matrix A. Then you now find the determinant of it. So also to find the determinant of this, 3 times minus 7 minus 5 times 4. So that should give us 3 times minus 7 minus 5 times 4. So this should give us minus 21, then plus 20, because minus 5 times 4 give us minus 20, times minus will give us plus. So we have minus 21 plus 20, and that will give us a minus 1 as well. So that simply means that the determinant of a matrix is equal to the determinant of the transpose of that matrix. So that means this is equal to this. So they can, another question in further mathematics is that they can ask to show that the determinant of a particular matrix is equal to the determinant of the transpose of that matrix, which is this. So this is equal to this, as you can see clearly in this solution. Now let's see another implication of this determinant. Determinant can help us to do another some things in the matrix. Like you have to find the value of x for which this you have to find the determinant of this matrix equals to 0. So we are having these two straight lines, which means that this matrix you have to find the determinant of it, and is equal to what? 0. And we know that this matrix is given in terms of x. Here you're having 2 minus x, here you're having 1 plus 3x. So find the determinant of this equals to what? 0. You can use that to find x in that case. So how do we go about it? Of course, the same thing, you cross multiply like you have been doing before, and then you subtract. So 2 minus x multiplied by 1 plus 3x, and you know the reason why I put them in brackets. So the minus 2 times minus 5 equals to what? This 0 here. So that is, find the determinant of this matrix, then equate it to 0, which is what you're having here. From there, what do you do? Open the bracket. 2 times 1 will give us a 2, then 2 times 3x will give us a 6x, minus s times 1 will give us minus s, minus s times 3s will give us a minus 3s squared, then minus 2 times minus 5 will give us a plus 10 equals to what? 0. Then from there you can collect like times. So that will give us a minus 3s squared, then 6x minus x will give us a 5x, 2 plus 10 will give us a 12 equals to 0. Then I can multiply through by minus to eliminate this minus here. So if I multiply through by minus, you have a this times minus will give us a plus 3x squared. Multiply this one by minus, we have minus 5x. Multiply this one by minus, we have minus 12 equals to 0. And this is a quadratic equation now you have to solve using any method that you know. You can see that from matrix we are adding to quadratic equation. So we can solve this using any method you know, whether completely square method or factorization method or formula method. Anyone you remember you can apply, but I know I can solve this one using factorization method. So 3 will multiply minus 12 first, that gives us minus 36, and the two factors of minus 36 that can multiply together to give me minus 36, and when I add them together give me minus 5, and that should be minus 9 plus 4. Minus 9 times 4 will give us a minus 36. So minus 9 plus 4 give us minus 5. So if I return that here, that give me 3s squared minus 9s plus 4s minus 12 equals to 0. Factorize this, factorize this. So 3s is common here. You have 3s into s minus 3 plus 4 is common here. You have 4 into s minus 3 equals to 0. Then bring this and this together. That give us a 3s plus 4. Pick one of the bracket, s minus 3 equals to 0. So that means 3s plus 4 is equal to 0, or s minus 3 equals to 0. So from there you can find our x. S will be equal to minus 4 over 3, or s will be equal to 3 for the value of s that we have to find for this question. So we can see how we move from matrices to quadratic equation, and this as a result of the implication of a determinant of matrix. So if you understand what you have done under determinant of 2 by 2 matrix, then you can attempt this question on the screen right now. You have matrix P and matrix Q. You have to show that determinant of matrix P is equal to determinant of matrix P transpose. You have to find the matrix determinant of Q. What type of matrix is Q? They're asking you that question again, which is what you have done before. Then find the value of x, given that determinant of this matrix is equal to 0, and the same thing here as well. So you have to find value of x here, find value of x here as well, which is what you have solved previously. So that is that on the determinant of 2 by 2 matrix. Now we are going to talk about determinant of 3 by 3 matrices. Like I told you, we can find the determinant of any square matrix, whether 2 by 2 or 3 by 3. We have just concluded 2 by 2. Now we want to go to about 3 by 3 matrix. How do we find the determinant of 3 by 3 matrix? Of course, I've already explained the symbol for determinant, which is that two straight line. So when it comes to 3 by 3 matrix, now we are having 3 by 3 matrix. Then instead of using that curve bracket, we are now having two straight lines to enclose the 3 by 3 matrix. So, and how do we simplify? How do we find the determinant of that 3 by 3 matrix? So to find the determinant of 3 by 3 matrix, first reduce the 3 by 3 matrix to 2 by 2 matrix with the positional log sign of the first row. I will come again. To find the determinant of 3 by 3 matrix, first reduce the matrix to 2 by 2 matrix. That is, reduce this 3 by 3 to 2 by 2 matrix with the positional sign of the first row. What do we mean by positional sign of the first row? Now this is an example. This is a 3 by 3 matrix, A, B, C, D, E, F, G, H as the element in it, and you're having this straight line, which means determinant of this 3 by 3 matrix. Now this 3 by 3 matrix has positional sign. That is, each of these elements in this 3 by 3 matrix has positional sign. That is, they have sign that are not revealed to us. They have sign that they occupy. This position they occupy have a particular sign that is not revealed to us. And what are the signs? A here has positive, B has negative, C negative, sorry, positive rather. So the sign is like this. The positional sign of this 3 by 3 matrix here is like this. So the sign of this A here is positive, B is negative, C is positive, negative, positive, negative, positive, negative, positive. So this sign you are having here are for the elements in 3 by 3 matrix. So literally, if you want to find the determinant of 3 by 3 matrix, we will need the positional sign of the element in the 3 by 3 matrix, but not all of them. We need only the first row. So the positional sign of this element here is a plus. Positional sign of B here is a minus. C here is a plus. So you are not going to use everything, and that is the rest is left for this further mathematics student when they want to find the cofactor of a matrix. So when we get there, we will use that. But for determinant of 3 by 3 matrix, we need the first row, the positional sign of the first row we need, and we will now reduce this 3 by 3 matrix to 2 by 2 matrix. So let's see how we do that. Now we have this 3 by 3 matrix saying that we have to find the determinant of it. So I said we are going to use this positional sign of the first row. Now how do we do that? Now to find the determinant of this 3 by 3 matrix, the positional sign of this, we are going to use this element, the first element here, which is the element in the first row, first column, which is A, and we are going to use this positional sign, which is plus. So then we are going to use that sign, that element with its sign, which is plus A. Then we will now reduce this 3 by 3 matrix to 2 by 2 matrix by closing the row where this element belongs to, which is this first row. You close it, and the column which this element belongs to, which is this column, we close it as well. So you close this first row, you close this first column. So then we are left with this element E, F, H, and I, which is also 2 by 2 element matrix that is left. So also for the second one as well, the positional sign of this one is negative, so we have minus B here. Then also you close this row that this element belongs to, which is this first row, and it belongs to this second column. So you close this first row, you close this first second column. So we are left with D, F, G, and H, which is 2 by 2 matrix. Then the last one, which is for this positive, which is for C, which is positive, you write plus C. Then this C is in the first row, third column. So you close the first row, third column. Also we are left with D, E, G, and H, which is 2 by 2 matrix as well. So if you do that, you have something like this. Now for the first one, the element here is A. You write the A with this positional sign, which is positive, so you have A. Then you now reduce this 3 by 3 matrix to 2 by 2 matrix by closing the first row that this element belongs to. This first row, first column, you close it. So close the first row, close the first column. So you have E, F, G, H left. So you'll be having A, then this two straight line, then E, F, G, H. That we are going to be having. So in that case, you have been able to reduce the 3 by 3 matrix to 2 by 2 matrix. So you'll be having A, then slash E, F, G, H, and I. You're going to write that very soon. Now, then the next one is that you're having minus, then this element there, which is B. So you'll be having minus B. You have minus B. Then you also reduce the matrix to 2 by 2. Then this element is in the element here is in first row. You close the first row, and the element is in the second column. So you close the first row, second column. So you'll be having first row close, second column close. So you have D, F, G, and H left. So you'll be having minus B, and then two straight line D, F, G, and H. You're going to write that very soon. Then the next one is this one is positive, which is for C. So you have plus C. Then reduce the 3 by 3 matrix to 2 by 2 by closing the row that this element belongs to. Close this first row, and this element belongs to this third column. You close the third column. So you are left with D, E, G, H. So close the first row, close the third column. You have D, E, G, H left. So you'll be having C, then two straight line D, E, G, H left. So which is going to give us something like this. For this one, you have this. For this, we have this one minus the B into this. Then for this, we have a plus this one. So like this, now you have been able to reduce this 3 by 3 matrix to 2 by 2 matrix using the first row, which is A, then B and C with their positional sign, which is a positive, negative, then positive. Do you understand that? So from here now we know what to do from here, because this is now 2 by 2 matrix. So we know how to find the determinant of 2 by 2 matrix. So you cross multiply, then you subtract. So that should give us a into bracket this multiplied by this, which is EI minus F multiplied by A, which is FH. There's a mistake. This one's supposed to be at the front here, this one be at here, so there's a mistake there, but nevertheless still the same thing if you rearrange. So minus B, then this multiplied by this minus this multiplied by this, which is going to give us this, then plus C into bracket this multiplied by this minus this multiplied by this, which is going to give us this. So there's a typographical error here. This is supposed to be at the front here, where this one come here, but nevertheless it's still the same thing. So I'm going to just showing you how to find the determinant of 3 by 3 matrix. When you get to the real calculation and you see how to do that. Okay, let's see how to find it. Let's find the determinant of this 3 by 3 matrix and see how we're going to do it based on what we just explained. Now don't forget the positional sign of this first row. 6 has a sign of positive, 3 has a sign of negative, 2 has a sign of what? Positive. So that's what we're going to use to find the determinant and reduce the 3 by 3 matrix to 2 by 2 matrix. Then if you do that, so the first thing you're going to have 6. Okay, you have to find the determinant of A, which is going to be written as determinant of A equals to, so you write the element 6 with its positional sign, which is positive. We have 6. Then reduce this 3 by 3 matrix to 2 by 2 matrix. So you close the first row, close the first column, because that's what this element belongs to. So if you close this row, close the first column. So you have close, you have close. So you are left with 0, 4, 2, 6. So you'll be having 6, then the determinant of 0, 4, 2, 6. So you have been able to reduce this 3 by 3 matrix to 2 by 2 matrix. Then the next one is minus 3 now. Minus 3 into determinant of 2 by 2. So you need to reduce this also to 2 by 2 matrix, because this 3 belongs to the first row, second column. So you close the first row, second column. So you have something like this as well. 7, 4, 5, and 6 left. That's what you have left. Then the sign of this one is positive for 2. So you have plus 2. Then the elements is in the first row, third column. So close the first row, third column. That means you have something like this. So you have 7, 0, 5, 2. So if I write this one out, you'll be having 6, then into the determinant of 0, 4, 2, 6 minus 3 determinant of 4, 7, 4, 5, 6 plus 2 determinant of 7, 0, 5 and 2. So we have been able to reduce the 3 by 3 matrix to 2 by 2 matrix now using the first row and their positional sign. Do we understand? Now from there we know what to do for this one. This is a determinant of 2 by 2, determinant of 2 by 2, determinant of 2 by 2, which we have done before. So by cross multiplying and subtracting, so here you'll be having 6 open bracket, 0 times 6 will give us 0, minus 4 times 2 give us 8, minus 3 into 7 times 6 will give us 42, minus 4 times 5 will give us 20, plus 2 open bracket, 7 times 2 give us 14, 0 times minus 0 times 5 give us 0. If you simplify further, 0 minus 8 give us minus 8 times 6, that gives us minus 48. 42 times minus 20 will give us give us 22. Then 22 times minus 3 give us a minus 66. Then 14 minus 0 is 14 times 2 give us 28. If you simplify this one further, you give us a minus 48 minus 66 plus 24 give us a minus 90. So that means the determinant of this matrix A is minus 90. So we are giving you to evaluate the determinant of matrix M, which is also 3 by 3 matrix, and we know what to do. We need to use the positional sign of the first row. Then we now reduce the 3 by 3 matrix to 2 by 2 matrix. So if you do that, we will be having a determinant of this matrix, which is written as the 2 straight line. Then you put the element of the matrix there. Then the next thing to do is to multiply use the element of the first row with their positional sign, then reduce this matrix to 2 by 2 matrix. So if you do that, we'll have something like this. And these are how you're supposed to do it in the first place. Then but those 2 questions that we wrote, those 2 questions that we have solved, or were just to help you understand how we go about reducing it to 2 by 2 matrix. Now this is how you're supposed to do it normally, and the first thing you do here is to write 2 with its positional sign. Positional sign of this 2 is positive, so you have plus 2 here. Then you now reduce this 3 by 3 matrix to 2 by 2 matrix, because this element is in the first row, first column. So you close the first row, close the first column, so you have a 0, 4, minus 1, minus 2 left. So with the determinant, then positional sign of this 5 is minus, so you have a minus 5. So you have write that positional sign with that 5, so you have minus 5. Then now reduce this 3 by 3 matrix to 2 by 2 matrix, because this element is in the first row, is in the second column. So you close the first row, close the second column. You have 3, 4, 3 and minus 2, which is what you're having here. Then the positional sign of this minus 6 is plus. Positional sign of this minus 6 is plus, so you have plus. Then you write the minus 6. Are you there? Then you now reduce this 3 by 3 matrix to 2 by 2 matrix. Then that means you need to close the first row, close the third column, because this element belongs to the first row, third column. So you are left with 3, 0, 3 and minus 1, which is what you have in this determinant. So like that, we have been able to reduce the 3 by 3 matrix to 2 by 2 matrix using the first row. So from there, you can now simplify by finding the determinant of this 2 by 2 matrix and multiply them by the value outside. So you have 2 into, if you simplify this, that will give us 0. 0 times minus 2 will give us a give us 0. Then minus 4 times minus 1, that will give us a minus 4. You still remember how to find the determinant of 2 by 2 matrix. So you have 0 times minus 2 give us 0. Then minus 4 times minus 1 give us minus 4. Then minus 5 into 3 times minus 2 give us minus 6. Minus 4 times 3 give us 12. Then plus times minus give us a minus 6 here. Open bracket. 3 times minus 1 will give us a minus 3. Minus 0 times 3 give us 0. From there, if we simplify further, plus times minus give us plus. So we have 4 plus 0, that give us 0. Times 2, that give us 8. So you have 2 times 4. You know how we got this for? This is plus times plus. Minus times minus give us plus. Then 0 plus 4 give us a 4. Then minus 6 minus 12 give us minus 18. Then minus 3 minus 0 give us a minus 3. So we have a 2 times 4 give us a 8. Minus 5 times minus 18 give us plus 90. Minus 6 times minus 3 give us a 18. If you add them together, give us a 116, which is the determinant of this 3 by 3 matrix M. Alright, this is another way they can present the question. You have to solve, which I believe you know the meaning of this. You have to solve the determinant of this 3 by 3 matrix, and it's very simple as well. You are using the first row to multiply when you reduce this 3 by 3 matrix to 2 by 2 matrix. So if you do that, that will give us the sign of this one is positive. You have plus open bracket minus 9. Then reduce this back to 2 by 2 matrix, close this, we have this left. Then the sign of this one also is negative, so you have minus open bracket minus 2 here. Then reduce this to 2 by 2 matrix, you close this first row, close the second column, so you have a 6 0 minus 9 and 2 left, which is this, plus the sign of this one is positive, so you have plus 5. Then reduce this back to 2 by 2 matrix, close this, you have a 6 minus 1 minus 9 and 7 left, which you can now simplify further. Plus times minus give us minus 9 there, cross multiply here, minus 1 times 2 give us a minus 2, then minus 0 times 7 is 0, then minus times minus 0 give us a plus, then 2 open bracket 6 times 2 is 12, minus 0 times minus 0 times 9 will give us 0, which is going to be plus 0. Then plus 5 into 7, 6 times 7 give us a 42. Then minus 1 times minus 9 give us a plus 9. Minus 1 times minus 9 will give us a plus 9. Then there is a minus there before, so we have minus 9. Do you understand what you have, how we got this minus 9? Minus 1 times minus 9 will give us a plus 9. Then there was a minus there because we are supposed to subtract the this minus this when you cross multiply, so that minus is what you're having here. Then minus times minus here will give us plus, so we have minus 9 here. So if you simplify further, we have minus 2 minus 0, that gives us a minus 2 times minus 8 minus 9 rather, that gives us a this. So you have a 12 plus 0 is 12. You have a 42 minus 9 is 33. If you open the bracket, that will give us a 18 plus 24 plus 165. And if you add them together, that gives us a 207 as the determinant of this matrix. So another thing we can do with the determinant of 3 by 3 matrix is to find the value of the unknown in the element of the 3 by 3 matrix, just like we did under 2 by 2. In this case, you are told that the determinant of this matrix is equal to 2. You have to use that to find the value of x. So it's still very simple as well. You are solving it the way we find the determinant of 3 by 3 matrix, using the first row and reduce this matrix to 2 by 2. So here you'll be having 3, then close this, you have a 1 1 3 s and 3, you have a minus 2, close this, you have 4 1 and 3, then you have plus minus 1, then close this, you have 4 1 x equals to 2, which is going to be what you are having here, which I believe you understand how I got this now. I just explained that here. So you have reduced this 3 by 3 to 2 by 2 using the first row here. And if you simplify this determinant of 2 by 2, determinant of 2 by 2, determinant of 2 by 2, then you'll be having 3 into cross multiply, you have 3, minus cross multiply, you have x, then minus 2 into cross multiply, you have 12, minus cross multiply, you have 1, then plus and minus open bracket cross multiply, you have 4s, minus cross multiply, you have minus 1 equals to 2. Open the brackets, we have a 9 minus 3x, then this is 12 minus 1 is 11 times minus 2, we have minus 22, minus 1 times 4 will give us a minus 4s, then minus 1 times minus 1 will give us a plus 1 equals to 2. Collect like times minus 3s minus 4 will give us a minus 7x. So 9 minus 22 plus 1 will give us a minus 12 equals to 2. Take minus 12 to this side, we have a minus 7x equals to 14. Divide both sides by minus 7, x will be equals to minus 2. So which is one of the implication, or one of the use of a 3 by 3 determinant of 3 by 3 matrix. So if you understand how to find the determinant of 3 by 3 matrix, these are questions for you to attempt by yourself, which means you have to find the determinant of this 3 by 3 matrix, find the determinant of this, find the determinant of this, then find the value of k here using the determinant of 3 by 3 equals to 23. So you can send your answers to me via my email that I'm going to publish very soon on my channel or in this video, so as to get in touch with me in order to help you confirm whether you are right or wrong after solving this question. So that's solution for question, or that's all about a determinant of 3 by 3 matrix. Now the next thing to talk about is equality of matrices. Equality of matrices, that is, how do we find equality of matrices, and what is the implication of the equality of matrices. Now to find equality of matrices, it means that two matrices are said to be equal if they are of the same order and their corresponding elements are equal. That is the implication. Two matrices are said to be equal if they are of the same order, 1, and their corresponding elements are equal. So they are equal because they are of the same order, 1, and their corresponding elements are equal as well. So for an example, we have this 2 by 2 matrix equals to this 2 by 2 matrix, and it means that A is equal to E, B is equal to F, C is equal to G, D is equal to H. That's the implication of their equality. So this 2 by 2 is equal to this 2 by 2, and the element here is equal to the element here, and so on. So that's the implication, and this we can use to do some things or solve some problem in matrix. Let's see that you have to find the value of x and y for which this matrix multiplied by this matrix is equal to this matrix. So of course we know that this matrix is multiplying this matrix equals to this matrix, so we have to find the value of x and y. So we have an equality sign here saying that the left hand side is equal to the left hand side, but we cannot apply the equality of matrix here until we have a single 2 by 2 matrix here and a single 2 by 2 matrix here. That's why you cannot compare both sides. But in this case now, this matrix is multiplying this matrix, so you need to multiply them out to give us a 2 by 2 matrix. Then you can now apply the equality of matrix. So let's see that in action. So this matrix will multiply this matrix first, and the question is, can they multiply based on our idea of multiplication of matrix? Today the condition of multiplication of matrix, is it satisfied here? Yes, it is. The element in the row here is 2, the element in the column here is also 2, so that means they can multiply. So the condition is so let's multiply them out. Now of course we know that the row will multiply the column, this row will multiply this column, this row will multiply this column, then this second row will go, the second row will also go, and so on. So if you multiply, so 3 will multiply x, we have 3x, plus 2 will multiply 4, that gives us 8. Then this row will also multiply this column, so we have 3 times 5, that gives us 15, plus 2 times y give us 2y. Then the second row also will go, minus 1 times s will give us minus s, plus 4 times 4 will give us 16. Then the second row will also multiply the second column here, you have minus 1 times 5 give us minus 5, plus 4 times y will give us 4y, equals to this matrix. So we can see that this is now 2 by 2 matrix in terms of x and in terms of y. So this is 2 by 2. So the implication is that this left hand side is equal to the right hand side. So that means everything here represents the element in the first row, first column. Everything here represents the element in the first row, second column. Everything here represents the element in the second row, first column. Everything here represents the element in second row, second column. So that means 3s plus 8 will be equal to 2, 15 plus 2y equals to 21, minus s plus 16 equals to 18, then minus 5 plus 4y equals to 7, which we can now use to find our s. So 3s plus 8 will equal to 2, so we can find our s from there. So collect like times 3 equals to 2 minus 8, that gives us 3s equal to minus 6, divide both sides by 3, s equals to minus 2. We can also do that here as well. We still get the same answer. So we have minus s plus 16 equals to 18. We still get our s to be minus 2 as well. So we don't need to repeat ourselves. So to get our y, we have 15 plus 2y equals to 21. That is, this is equals to 21. 15 plus 2y equals to 21. Collect like times, you have 2y equals to 21 minus 15. 2y equals to 6. Divide both sides by 2. S will be equals to 3. So therefore our s is minus 2. Our y is equal to 3. Using the idea of equality of matrix in this case. So let's see another question. Given that this matrix multiplied by this column matrix is equal to this column matrix, find the value of x. So of course, having equality here, you cannot apply equality of matrix here until you make this is a column matrix to look like this as well, so that you can now compare both sides. So if you do that, you know that this matrix will multiply this matrix. The question is, can they multiply? Yes, the row will multiply the column. So 2 elements in the row, 2 elements in the column, so they will multiply. So that means this row will multiply this column, then this second row will also multiply this column as well. So you have 3 times x, that will give us 3x plus 4 times y, give us 4y. So that means we'll be having something like this: 3x plus 4y, then minus 2 times x give us a minus 2x plus 5 times y give us 5y equals to this column matrix. So that means you're having a column matrix equals to a column matrix, and you can now compare. So that means this will be equals to minus 3, then this will be equals to this as well. So that should give us 3s plus 4y equals to minus 3, minus 2s plus 5y equals to 25 as well, equation 2. We can now solve these two equations simultaneously now to get our x and y. So we can multiply equation 1 by 2, multiply equation 2 by equation 1 by 2, multiply equation 2 by 3, so as to eliminate x using elimination method. So if we do that, we have we multiply this one by 2, we have 6s plus 8y equals to minus 6. Multiply this one by 3, we have minus 6x, then plus 15y equals 75. Then we can now add equation 3 and equation 4. So add equation 3 and 4 to eliminate x. So this plus minus this, that give us 0. 8y plus 15y will give us 23y. Minus 6 plus 75 give us 69. Divide both sides by 23. Y will be equals to 3. So you can put this one into equation 1 or equation 2 to find our x. So 2y equals to 3 into equation 1 to find x. So you have 3s plus 4y equals to minus 3. If you put that there, you have 3s into 4 multiplied by 3 equals to minus 3, because our y is 3. So you have 3s plus 12 equals to minus 3. 3s equals to minus 15. If you take 12 here, you have minus 15. Divide both sides by 3, s will be equals to 5. So our s is minus 5, our y is equals to 3, which we are still using implication of equality of two matrices. So that is that about equation of equality of matrix and the implication of that. So if you understand that, please try this question on the screen right now. You have to determine the value of p plus q if you are given this matrix to multiply this matrix equals to this matrix. So also you have to find the value of x and y from here, and also you have to find the value of m and n from here as well, using the idea of equality of matrix. So the next thing on our agenda now is how to find inverse of a matrix, in this case inverse of 2 by 2 matrix. So you can also find, literally we can find the inverse of a square matrix as well, which is 2 by 2 and 3 by 3, but 2 by 2 is meant for general mathematics student, while 3 by 3 is meant for further mathematics student. So that means in the next video we're going to be talking about how you can find the inverse of 3 by 3 matrix. So how do you find the inverse of 2 by 2 matrix now, as far as this video is concerned, for general mathematics student? So the inverse of a matrix, if there is a matrix A, therefore its inverse will be named A raised to power minus 1, which I believe we know using our indices. So the inverse of matrix A is written as A raised to power minus 1. So, and how do you calculate inverse of any matrix? the inverse of matrix A is equal to adjoint of matrix A over the determinant of matrix A. So determinant of matrix A is written is a adjoint of matrix A over determinant of matrix A. So an adjoint of matrix A is cofactor transpose. C is representing cofactor of a matrix A. Then you transpose whatever you get. So that is why when you get to further mathematics, students are meant to know what is called cofactor of matrix, mostly 3 by 3 matrix. So those are the things we are going to be talking about in the next video, not in this video. So for further mathematics students, but I would just want you to know that the inverse of a matrix is adjoint of that matrix over the determinant of the matrix. But adjoint of a matrix is cofactor of the matrix, then transpose the cofactor. Do you understand now? Now we are going to be doing that in this 2 by 2 matrix, but we are going to use shortcuts. We are not going to be finding cofactor at all. There's a way we can go bypass this, but I'm giving you this so as for the mathematics student to be aware of this, so that by the time you are using it in the next video, they will understand what we are doing. So to find the determinant of a matrix, we need the adjoint of that matrix over determinant of the matrix. Now that means the inverse of a matrix can be written as cofactor transpose of the matrix over determinant of that matrix, where we know that this one represents adjoint of the matrix. Now let's go ahead and see how that in at work. We have matrix A here which have these elements. We have to find the inverse of that matrix. So we know that the inverse of this matrix is cofactor transpose over the determinant of this matrix. Let's first of all get the cofactor transpose before we get the determinant. By now you know how to find the determinant of this 2 by 2 matrix. All we don't know now is you don't know how to find cofactor transpose. Although we know how to find transpose, but we don't know how to find cofactor. Then we are going to do this one. We are going to do it straight. This cofactor transpose, we are going to do it once by using shortcuts. We are not going to use the long process. And how do we do that? Now to find the adjoint of a matrix, which is cofactor transpose. Now what you do is that this matrix you are having here, it has 2 diagonal, like you know when you are finding the determinant, it has 2 diagonal. So to find the cofactor transpose, what you do is that switch this diagonal here, switch it. This 5 will come here, 3 will come down here. So you have 5 here and 3 will come here. So if you switch it, you have a 5 and 3. Then the second diagonal, don't switch it, just multiply this one by minus, multiply this one by minus as well. So if you multiply this one by minus, this one becomes +2, and if you multiply this one by minus, that will give us -4. So that's how to get cofactor transpose, which is what we will need here. Like I said, this has 2 diagonal. The first diagonal, switch it, you have 5 and 3, but the second diagonal, don't switch it, you have 2. Sorry, you don't switch it, but you multiply it by minus. You multiply this by minus, you multiply this by minus, that gives us 2 and -4. So this is the cofactor transpose of this matrix A. Then let's find the determinant of A. So we know that determinant of A is that you need to cross multiply and you subtract. So this 3 times 5 will give us this, minus 4 times -2, which is this, and that will give us a 15 plus 8, because -4 times -2 gives us a +8, and that gives us 23. So if you return that into this formula, therefore the inverse of A, which is cofactor transpose over determinant of A, will give us this cofactor, which is this matrix, over 23, and this can be written as 1 over 23 multiplied by this matrix. So whatever you are having here is the inverse of this matrix. So the inverse of this matrix A is this 1 over 23 multiplied by this matrix here, and we know that this 1 over 23 is multiplying each element here in the matrix, from idea of our scalar multiplying a matrix. So but you can leave your answer like this, or you can use this 1 over 23 to multiply each element in the matrix, but this is the inverse of this matrix A. Alright, you have to find the inverse of the matrix, this matrix here, which is also 2 by 2. So how do we go about it as well? It's very simple. We need to find the cofactor of this cofactor transpose of this matrix over the determinant of this matrix. So which is what you have here, the inverse of this matrix, which can be written as this matrix raised to power -1. Since we did not give this matrix a name, you can just write the matrix raised to power what, -1, which is representing the inverse. which is going to be cofactor of the transpose of the matrix over determinant of this matrix. Then we know how to find the cofactor transpose. Switch this diagonal, then this second diagonal, multiply by minus. So that will give us if you switch this one, you have 8 and minus 3, and if you multiply this diagonal by minus, you have minus 6 and minus 5. So what you have, the numerator here is the cofactor transpose of the matrix. Then you now to find the determinant of the denominator. So you cross multiply, you have minus 3 times 8, which is this, minus 5 times 6, which is this. And if you simplify that further, you have this cofactor transpose, which is this. This will give us minus 27, so minus 24, then minus 30. So that should give us the cofactor transpose over minus 54, which can be written as minus 1 over 54 multiplied by this. So that is the inverse of that matrix. So if you understand how to find the inverse of matrix based on what you have done so far, try these 3 questions to find the inverse of each of these 3 questions. And if you don't understand, please repeat that. You can repeat the explanation that I just made on the inverse of matrix to understand it. Now the next thing we are going to be doing is the solution to simultaneous equation. Solution to simultaneous equation. We can use matrix to solve simultaneous equation. I know you'll be surprised that we can use matrix to solve simultaneous equation. I know in previous classes that you have been, we can solve simultaneous equation using elimination method or substitution method or graphical method. But now, as a S3 student, you should know that we can solve simultaneous equation using matrix as well, and that's what we want to see under this topic, solution to simultaneous equation. So in solving simultaneous equation using matrix, there are 2 methods we can apply. So we have 2 methods to solve simultaneous equation in matrices. The first method is called determinant method, and the name of that method is called Cramer's rule. So in solving simultaneous equation using matrix, we can use the first method is we use determinant method, and another name for determinant method is Cramer rule. Cramer's rule. Cramer was a mathematician. He was the one who formulated this method, and he named it after himself. And another name for Cramer's rule is determinant method. So in examination, they can call it Cramer's rule or they can call it determinant method, but you should know that they mean the same thing. Then the second method is a matrix method, which is called inverse method. So these are the 2 methods we can use to solve simultaneous equation in matrix. So please understand or try to know the 2 methods very well and their names, because if you are to use inverse method to solve the question and you will not go and use determinant method, even though you get the same answer, you are wrong, because this method is different from this method. Just like you know, in quadratic equation, you have different methods you can use, either factorization method, complete square method, formula method, or the what's it called, graphical method, knowing fully well that all these methods will give all the same answer. So but if they made it compulsory that you have to use a particular method, you cannot use other methods. So in this case as well, they can say use determinant method to solve the simultaneous equation. Don't go and use matrix. Or if they say you should use matrix, don't say because I know determinant method, I want to go and use determinant method. You will be wrong. So that is why you are meant to know the 2 methods very, very well. Determinant method is the same thing as Cramer's rule, and matrix method is the same thing as inverse method. So matrix method means inverse method. Now let's start with the determinant method. Now determinant method of solving simultaneous equation. So for instance, you are to use determinant method to solve this simultaneous equation. We have 5x plus 2y equals to 17, and we have 2x minus 3y equals to 3. So equation 1, equation 2. So you have to use determinant method to solve these simultaneous equation. So how do we go about that using determinant method now, which is Cramer's rule? The first thing to do is to separate the equation of the variables from the variable and represent it in a matrix method. Sorry, I made a mistake there. Separate this equation of the variable there, and separate the equation of the elements coefficient of this variable, separate them from the variable and represent it in matrix form. Represent it in matrix form. That's the right thing to say. Separate the coefficient of this variable from the variable and write it in matrix form. How do we do that? The coefficient of x here is 5, coefficient of y here is 2, coefficient of s here is 2, coefficient of y here is minus 3. So if you write that, that will be in bracket you have 5, 2, 2 minus 3, then to multiply x and y, which is a column matrix. Because if this multiply this, you are going to have this back from idea of multiplication of matrix. If this one multiply this one, you are going to have this back, because 5 times l will give us 5s plus 2 times y will give us a 2y. 2 times l will give us 2s plus minus 3 times y will give us a minus 3y. You understand that now? So separate the question of the variable from the variable and write it in matrix form, multiply by the variable, equals to represent this answer also in column matrix as well. You have a 17 and 3 as well. Do we understand that? Then after you represent this in matrix form like this, the next thing to do is to find change, and change is the determinant of this matrix, and that is where determinant comes from, determinant method. So you have to find change, which is you find determinant of this 2 by 2 matrix. So change equals to determinant of this 2 by 2 matrix, and if you find determinant of this 2 by 2 matrix, you have a 5 times minus 3, that gives us minus 15, minus 2 times 2 give us 4, and that should give us a minus 19. So that means the change, which is determinant of this matrix, is minus 19. Then the next thing to do is to find change in x. Change in x, because our aim is to find x and y. So you find change in x first. What's the meaning of change in x? This column matrix here, which is the answer, we replace this column which belongs to x. Don't forget that this column belongs to x here. So that means this value, this column matrix here, will replace this column of x. You now find the determinant of that. So you have change in x to be 17 and 3, which is this column matrix. We replace this one here, you are left with this one. So you have 17, 3, then 2 and minus 3, which is this one. So that means you have been able to use this to replace the column of x, and we now call it change of x. We now find the determinant of that. Do we understand that? So if we cross multiply, minus 3 times 17 give us minus 57, minus 2 times 3 give us 6. Simplify that, that will give us minus 57, which is for change in x. Then the last one you do is to find the change in y as well. That means this column matrix also will replace this column of y, because this column belongs to y. So this also will replace this one here. So you are left with 5, 2 and 17 and 3. So this is going to be like this. You have change in y with determinant of 5, 2, 17 and 3. So if you find determinant of that, 5 will multiply 3, that give us 15, minus 7 times 2 give us a minus 32. If you subtract that, that will give us a minus 19. So we have change, you have change in y, sorry, change in x, you have change in y. So our aim is to find our s and y. So how do we find x? S will be equals to change in x divided by change. So change will cancel change here, you have x left. So what's our change in x? That will be minus 57 divided by change is minus 19. So this cancelled, you have s to be equals to 3. So also we do find our y. Our y is going to be change in y over change. Our change in y is minus 19. Our change is minus 19 as well. Cancel, that give us 1. So our s is equals to 3. Our y is equals to 1. So which is very, very correct. If you put our s here, 3 times 5 will give us 15. Our y is 1. 2 times 1 is 1. So 15 plus 2 will give us 17, which is correct. So that's how to use Cramer's rule or determinant method to solve simultaneous equation. Let's try another question to help us understand very well. Now, using Cramer's rule to solve the simultaneous equation, 7a minus 3b minus 20 equals to 0, and 3a minus 5b minus 3 equals to 0. So we have to use Cramer's rule, which is same thing as the determinant method. Of course, the first thing to do is that you can see that these questions and this one are not yet arranged properly. So we need to take our constant to this side and this constant to this side as well, so that it can give us a proper equation. So that should give us a 7a minus 3b equals to 20, because if minus 20 come here, it equals to 20. Then also here you have a 3a minus 5b equals to 3 as well. So now we have a proper equation to solve. So the next thing to do is to separate the coefficient of the variable from the variable and represent it in matrix form. So that should give us 7 minus 3, 3 and minus 5 into bracket, open bracket again, a and b equals to column matrix 20 and 3, which is going to be like this as well. If you understand what you have done that, how you have done that rather, then the next thing to do is to find the determinant of this matrix, which is what we call change. So we have change to be equal to the determinant of this matrix. So change will be equal to determinant of 7 minus 3, 3 and minus 5, which will give us, if you cross multiply, you have minus 35, then minus 3 times 9 will give us a minus 9. That should give us a minus 35 plus 9, that gives us minus 26. Then the next thing to do is to find change in a. Our aim is to find a and b, so our change in a. So change in a will be, you need to use this column matrix to replace the column of a here, because this column belongs to a. So this 20 and 3 will replace this 7 and 3 here. So that will give us a 20 and 3, then minus 3 and 5, which is for this. Then now find the determinant of that as well. So we cross multiply, that should give us a minus 100, then minus open bracket minus 3 times 3 give us minus 9 as well. So minus 100 minus minus times 1 will give us a plus here. So you have a minus 100 plus 9, that gives us a minus 91. The next thing to do is to find change in b. So change in b will be equal to the absolute value. So this 20, this column matrix also will replace this column of b as well. So you are left with 7 and 3, 20 and 3 as well. You now find the determinant of that. So that will give us 7 times 3, that gives us 21, minus 20 times 3 give us minus 60. So if you subtract, that will give us a minus 39, which is for change in b. So therefore our a will now be changing a over change, because change cancel change, you have a left. So we have minus 91 over minus 26, and if you reduce that, that will give us a 7 over 2. For change, for our b as well, that will be changing b over change, because change cancel change, you have b left. So that will be minus 39, which is for changing b over change, which is minus 26. If you reduce that, that will give us a 3 over 2. So technically our a will be 3 over 1 over 2, and our b will be 1 over 2 if we change this one to a mixed fraction, which is the solution to the simultaneous equation. So using the determinant method. Now the next method you are going to do now, you are going to do the inverse method now, which is the second method. We are going to use inverse method to solve simultaneous equation now. Now that we have understood determinant method, which is called Cramer's rule, let's see the matrix method, which is called inverse method. So we are going to solve these two questions we have solved using the determinant method. We are going to use it. We are going to use the matrix method to solve those two questions again and see whether we are going to get the same answer or not. So we are going to use a matrix method to solve the two questions we have solved previously using Cramer's rule and see whether you are going to get the same answer. So what does a matrix method says, or inverse method, from the word inverse? Now we know that we have got, you know how to find the inverse of 2 by 2 matrix. So we are going to be using that to solve, and you are going to be using that in this matrix method, or called inverse method. Now the first thing I want you to know is that let's go back to primary school or previous classes. When you have a b equals to c, and you want to make let's say b subject of the formula, so what do? I'm going to use this to explain this method. That's the reason why I'm bringing this up now. I will use it to explain this matrix inverse method. So if we make b subject of formula, that means you'll be having, you divide both sides by a, that means b will be equal to c over a. Is that correct? Good. And you agree that this can be written as b is equal to 1 over a multiplied by c. That it can be written like this: b is equal to 1 over a times c. Is that correct? Yes, because if this c multiply 1, you see you have c over a back. And in our index, we know that 1 over a means a inverse, which can be written as a b is equal to a raised over minus 1 c. Is that correct? Good. So if you understand this, that means you can use this same analogy to, you are going to use this same analogy under this matrix inverse method of solving simultaneous equation. So let me bring out the question. This is the question that we solve using under the question that we solve under Cramer's rule. The first question we solve, which is this one. Of course, we have to solve this using matrix method, which is inverse method. So the first thing to do also is to remove the question of the variable from the variable and represent it in matrix form. So that will give us this, which is what you have seen before. Now compare this and this now. Okay, this one and this one, they look alike, where A stands for this matrix, B stands for this matrix, and C stands for this matrix. Is that correct? Good. So if I make, our aim is to find this column matrix, which is our unknown. We have to find S and Y. So that means I can divide both sides by this 2 by 2 matrix. I can divide both sides by this so that to get this one, which is what you are doing here. So if I divide both sides by this matrix, I will have this one left, which will be equal to this divided by this, which cannot be written as this one, cannot be written as this equals to the inverse of this matrix multiplied by this column matrix, which is what you are having here. Let me give you 1 second to think about it very well, see whether you are right, whether you understand it or not. Our aim is to find this column matrix. So we divide both sides by this. So if I divide this one by this, so this one will go here, it will leave, you have this one left. I divide this one by this as well, so we have this over this column matrix, which can be written like this. This column matrix raised to power minus 1 multiplied by this column matrix here. So what you have done here is what you have done here as well, it's just that we have skipped some step. So we jump from here to this point, making this a sorted of the formula. In this case, we made this sort of formula here. A comes to this side, and that A become minus A raised to power minus 1. So this one also come to this side, become this bracket raised to power minus 1 multiplied by this column matrix. Do we understand that? Okay, if you understand, but we know what this one means, raised to power minus 1. It means that you need to find the inverse of this 2 by 2 matrix. Then whatever you now get, it will now multiply this column matrix. Then you'll be able to find your S and Y from there. So we need to find the inverse of this 2 by 2 matrix, which is what we have done before under inverse of matrix. So let's do that now. Now we have to find the inverse of this matrix. How do we go about that? We know that inverse is cofactor minus cofactor of transpose minus so over determinant of the matrix. Cofactor transpose over determinant of the matrix. So the cofactor of this matrix, I taught you how to cofactor transpose of this matrix. I taught you how to go about that. This come here, you switch this one, that will give us a minus 3 and 5. And you multiply this the second diagonal by minus. Multiply this by minus, multiply this by minus. You have minus 2 minus 2. Then from there you now find the time over determinant of the matrix, which is what you are having here. So our aim is to find the inverse of this matrix. That's what you are simplifying now. We are coming back to this point. So after doing that, is find the determinant of the denominator. So we have this cofactor transpose over cross multiply here. You have a minus 15 minus 4. So that will give us this over minus 19, which can be written as a minus 1 over 19 multiplied by this matrix here. So that means the inverse of this matrix here is this, what you are having here right now. So that means this one now is coming to replace this one here. But before we return this one into here, we need to bring this minus 19 into this bracket here. So this minus 19 will multiply each element here from our idea of a scalar multiplying a matrix. So that should give us minus 1 over 19 multiplied by minus 3 give us 3 over 19. Then this time this will give us 2 over 19. Then 1 over 19 multiplied by minus 2 give us 2 over 19. Then minus 1 over 19 multiplied by 5 will give us minus 5 over 19. So this now we now replace this one here. So you'll be having S Y equals to the inverse of this matrix, which is this matrix here, multiplied by 17 and 3, which is a column matrix. So we'll now multiply this out now to get our X and Y. Now, can this matrix and this matrix multiply? Yes, they can multiply. 2 elements in the row, 2 elements in the column. So you multiply them out. So that means this row will multiply this column first, and this row will multiply this column again. So you're having 3 over 19 times 17. So that should give us 51 over 19 plus 2 over 19 times 3. That will give us 6 over 19. Then the second row will go again and multiply 2 over 19 times 17. That gives us 34 over 19 plus open bracket minus 5 over 19 times 3. That gives us a minus 15 over 19. Close the main bracket. Can now simplify this one. Here you're having a column matrix as well. This is a column matrix. Everything here represents the first row, first column. Everything here represents the second row, first column as well. So this is a column matrix as well, just like what you're having here. So if you simplify it by finding the LCM, you will be having a SY equals, so this is, find the LCM, this is 19. That gives us a 51 plus 8, that gives us 57 over 19. Then plus and minus give us a minus, so you have 34 minus 15 over 19, that gives us a 19 over 19. So 19 can go in 57, that gives us 3. 19 can go in 19, that gives us 1. So you have X column matrix equals to 3, 1, which is column matrix. And with the idea of equality of matrix, that means X will be equal to 3, then Y will be equal to 1, which is the same answer we got when we solved this question using Cramer's rule. So we still got the same answer when we solve it using this inverse method as well. So we can see that we have the same result after applying this inverse method. So let's solve the second question we solve under the Cramer's rule as well using this inverse method, which is this question again. You have to use inverse method to solve the simultaneous equation 7a minus 3b minus 20 equals 0, and this as well. So like I told you under that Cramer's rule that you need to follow change collect like times here. So you have 7a minus 3b equals to 20, 3a minus 5b equals to 3. So all you need to do is to change remove the represent this one in the matrix form. I believe you know what you do. This will give us 7 minus 3, 3r minus 5 multiplied by a column matrix A and B and equals to a column matrix. So that will give us this. So like I said, you need to make this one a sort of formula. This one will come here. So this will be, when it get to this side, become inverse. Then we multiply this. So that will give us what you're having here. So that means we need to find the inverse of this matrix. Whatever you now get, you now bring it back here to multiply this column matrix. So I can find our A and B. So we need to find the inverse of this matrix now. And that should give us the inverse of this matrix will be cofactor transpose over the determinant of that matrix. And how do we get the cofactor transpose of this matrix? So that should be, if you switch this one come here, which should become minus 5, this one come 7. So you have minus 5 and 7. Then this one you multiply by minus, you multiply this one by minus, you have minus 3 and 2, sorry, and 3 rather, over the determinant of this matrix, which is this here. So we need to find the determinant of this matrix. So if you do that, that will give us cross multiply 7 times minus 5 give us minus 35 minus 3 and times minus 3, that will give us minus 9 times minus 2, that give us plus. So we have this over minus 26, because plus 9 minus 35 plus 9 give us a minus 26. So this can now be written as minus 1 over 26 multiplied by this cofactor of transpose. So but we need to bring this one inside here. So this one will multiply each of the elements here so that they can now return it back here. If you do that, that will give us the inverse of the matrix will now be minus 1 over 26 times minus 5 give us 5 over 26. Then this multiplied by 3 will give us a minus 3 over 26. This times minus 1 over 26 times minus 3 give us 3 over 26. Then this time this will give us minus 7 over 26. So the inverse of this matrix here is this matrix. So this will now replace this one here, and you can now multiply them out. So you're now having this column matrix, which is in form of A and B, equals to the inverse of this matrix, which is this. We now replace this one here, then equals multiplied by this one. So this matrix now will now multiply this matrix to be able to get our A and B. Do you understand that? So can this one multiply this one? Yes. 2 rows, 2 elements in the rows, 2 elements in the column. So let's do that in the next slide. So you have to multiply this one by this. So this row will multiply this column. This second row will also multiply the column here as well. So if you do that, you have 5 over 26 times 20, that gives us 100 over 26. Then plus, then minus 3 over 26 times 3, that gives us minus 9 over 26. So that will give us this. So you have 100 over 26 plus minus 9 over 26. Then also this row will multiply this column as well. 3 over 26 times 20, that will give us 60, because okay, will give us a 60 over 26. Then plus minus 7 over 26 times 3, that gives us a minus 21 over 26. Then close the bracket. Then from there, minus times plus will give us a minus, so that will give us 100. Of course, you find the LCM, that will give us 100 minus 9 over 26. Here also, that will give us a plus, and that will give us a minus. So if you find the LCM, that will give us a 60 minus 21 over 26. If you simplify that further, 100 minus 9 will give us a 91 over 26. Then 60 minus 21 will give us 39 over 26 as well. Of course, this can go 26 can go in 91, or you can reduce this one. That will give us a 7 over 2. Then that will give us 39 over 26 goes to 3 over 2 as well. So that means your A will be 7 over 3, which is similar to 3 over 1 over 2, and your B will also be 3 over 2, which is equal to 1 over 1 over 2, which is the same answer we got when we use Cramer's rule, which is the determinant method. So you can see that we get the same answer when we use these two methods. But please be vigilant that any method they ask you to use, whether Cramer's rule or inverse method, please stick to it. Don't say that because Cramer's rule is simpler than inverse method, you want to know Cramer's rule alone. Please make sure that you know the two methods, so that anyone they ask you to use, you can always use them at any time. So if you understand the simultaneous equation using Cramer's rule and the inverse method, please attempt these two questions. You have to use both determinant and matrix method to solve the simultaneous equation, this and this one. So you have to use the two methods, both Cramer's rule, which is determinant method, and the matrix method, which is inverse method, to solve this question and to solve this question. And I want to see your answer in the comment section of this video. So that will end our discussion for this video, and I know that you can see that there is a long video and which cover everything that's said in the content of the video, the table of the content of this video at the beginning. So, and I want to believe that you have learned one or two things in this video. Like I promised, the next video we are going to be talking about the other topic that the students are meant to know in further mathematics, like inverse of 3 by 3 matrix, cofactors of a matrix, and how to find the solution to simultaneous equation of 3 by 3 matrix as well. So those are the things that further mathematics students are meant to know, which I'm going to be addressing in the next video. Please, before we go, if you are yet to subscribe to this channel, please click the subscribe button on the channel right now, so as to know whenever we post information on this channel. Share this video with students out there, most especially the students who are going to be needing this in general mathematics and further mathematics. And like this video, comment in the comment section of this video, give it a thumb up, and I'll see you in the next video. Thank you and God bless you. Bye.